Alright, welcome back to one more session of your alcohols, phenols and ethers chapter. We are very close to the board examination and it's okay. Vani ma'am is there with you all, right? Yes, students, so we started our preparation last month and for the whole year we have been studying. Now this is the right time for me to do the organic chemistry revision series. Now in this chapter, as I did for haloalkanes and haloarenes, without wasting time, I'll quickly give you the summary of what we are going to do and what is the advantage of watching this video. Yes. So your alcohols, phenols and ethers chapter, basically for your board examination, the weightage of the chapter is 6 marks. Correct na? So 6 marks chapter, a lot of confusion, everybody tension, don't worry, relax. In this video, I'm going to teach you the topic. I'm going to make you do, or I will do with explanation your MCQs. I'll be doing your 1 mark questions, I'll be doing 2 mark questions, I'll be doing 3, I'll be doing 4, I'll be doing 5. Yes, you heard it right. In detail explanation. Ma'am, if I watch this video, is it enough? It is 100% enough. Because in alcohols, phenols and ethers chapter, you have 5 mechanisms that you should study. You have conversions where you're converting phenol to different products. You're converting alcohol to different products like aldehydes, ketones, acids. You have conversions of ethers also. So I will be doing pin to pin. All questions are cherry picked. Very detailed. If you watch this video, you will only say, ma'am, my preparation is 100% over. Okay, so watch the video completely and most important, take a notebook, because till now we did all the chapters like solutions, electrochemistry, chemical kinetics, coordination compounds, D&F block and everything. Yes, so careful, don't worry, don't panic. Also, what you should do is you have to first understand how I am dealing it. Leave it to me. I'm going to teach you conversions, I'm going to teach you distinguishing test, I'm going to teach you paragraph based questions. I remember this. In ethers chapter, paragraph based questions they'll ask. Ma'am, what are paragraph based questions? Means they'll give you a situation where a compound A reacts with potassium dichromate in acidic medium and give compound B. Compound B then further reacts. In that way, they're going to give you a paragraph question where you're going to identify A, B, C, D, E like that. So I will train you. I'll give you a trick in each question how you're going to do in the board exam. Right? Nothing to worry. Believe me, your Vani ma'am, your world of chemistry is with you all. Chalo, quickly, yesterday I have sent you your haloalkanes, haloarenes chapter. Quickly watch that video, finish it off and let's start this video without wasting time. Give me a smile. Smile. It doesn't cost anything, isn't it? Chalo, let's start the video. Thank you. Alright students. So let us start our complete organic chemistry revision series. As you all know, we have started a board exam preparation, that's for your 2025 grade 12. Till now we have completed a chapter that is haloalkanes and haloarenes. Yes. Other than this, we also have completed your solutions chapter, we have completed your electrochemistry chapter, we have completed your chemical kinetics chapter, we have completed D&F block chapter, we have completed coordination compounds chapter also. Yes, coordination compounds also we have completed. Yes, so everything is kept in the playlist, students. Everything is kept in the playlist. That playlist is mentioned as 2025 board exam preparation. Yes, this is very important. Just check the board exam. Yes. Now today we are going to do a chapter that is nothing but alcohols, phenols and ethers. So nothing to worry. As haloalkanes and haloarenes, we will do a detailed study. So what will I do? I'm going to teach you topic and we are going to solve the MCQs. I'm going to teach you the topic. We will solve the 1 mark questions. We'll do 2 mark, we'll do 3, we'll do 4 and we'll do 5. My responsibility is I'll do 100% of the chapter. Watch the complete video. Yes, as you all know, organic chemistry weightage is 33 marks and remaining physical chemistry is only 23, inorganic is 14. So our target is to get centum complete 33. That is my responsibility. We will work together. Okay, chalo, let us not waste time and start the video. As you all know, your board exam, your theory paper, this is your 33 marks questions and it is a 70 marks paper. you all know we have to concentrate on your multiple choice questions. We have to concentrate on short answers. We have to concentrate on again 3 mark short answers, case based and long answer type. So we'll all work together. Let us not waste time. Let's rock it. Let's start. I request all of you to watch the earlier chapters also and join the Telegram, because the earlier chapters notes are provided in the Telegram. Let us start with your chapter, alcohols, phenols and ethers. Very cute chapter. Yes, before we start, as Vani ma'am always says, let us start with a smile. It doesn't cost anything. Na? Smile doesn't cost anything. So keep spreading smiles to everybody, whomever you love. Smile, smile, smile. That's it. Chalo, let's start. Now in your chapter, so in between some beep sound, students, that's my writing pad, which is a little bit bothering me, but I'll manage it. Points to remember: whenever you're doing any chapter, first you should have an understanding of the flow chart. What topics are there, what I have to study, because before your board examination, what happens is any topic which you leave, it will be a problem. Correct? Na? You may get questions from anywhere. So in alcohols, phenols and ethers chapter, flow chart we will do first. First you are going to study the classification, or rather types of different alcohols. So I am going to tell, we are going to study the classification. So in all the cases, whether it is in alcohols or phenols and ethers, we are going to study the classification in detail. Then we are going to study the IUPAC nomenclature with concept, with rules, with types and everything. IUPAC nomenclature is what I am going to. This IUPAC nomenclature we will study for phenols, we are going to study for alcohols, we are going to study for ethers also. This is very, very important. Then after this is over, I am going to teach you something called preparations. Yes, we are going to learn the preparations of the whole alcohols, phenols and ethers. Correct? Everything, all the preparations, alcohols required, phenols required, ethers required, for all the three we are going to learn. Yes, in detail. Then we are going to go into a topic called physical properties. And in that physical properties, we are going to learn about your boiling point concept. We are going to learn about solubility concept. We are going to learn about, I'm also going to discuss about melting point concept also here. Then after this, I'm going to take you into the chemical properties of your alcohols. So when we are studying chemical properties of alcohols, first of all, alcohols chemical reactions in detail we are going to study, very in detail. And most important thing, while studying this, I'm going to teach you mechanisms also. This chapter has mechanisms, students. You have mechanisms A, B, C, D, E. Okay, so many mechanisms I'm going to teach you in this chapter. And then from there, chemical properties of alcohols, I am going to go into chemical properties of phenols. So let us write here both the sides. This is chemical properties of your phenols. This is for phenols, and these are the chemical properties of your ethers. Chemical properties of your ethers. Okay, ethers. These two. So when you are studying chemical properties of the phenols, what are there? You have electrophilic substitution reactions. You have your Kolbe's reaction, very important. Then you have your Reimer-Tiemann reaction, Reimer-Tiemann reaction, RTR, Reimer-Tiemann reaction. Then reaction of phenol with zinc dust. Is there, then zinc dust. Then you have your reactions like oxidation reactions. Oh my god, so many. It's all are easy, correct? Na? Right? Then when it comes to ethers, you have your reaction. Williamson ether synthesis is there. So reaction with HI is there. HI. Then we are going to study about Williamson ether synthesis, Williamson ether synthesis, and all are there as a chapter. Apart from this, we are also going to study about electrophilic substitution reactions of anisole. Yes, this is very important and easy as well. In that, we will be studying about halogenation, nitration, Friedel-Crafts reaction. Along with this, we have conversions, very important conversions I'll be doing. Then we will be doing distinguishing tests also. We will also be doing the Lucas test. On all these, everything are included in this video. Okay, don't leave the video. I request all of you to please watch the video till the end. Now, before I go into the video, as I said, mechanisms, very important mechanisms, because from this mechanism they may ask you MCQs, they may ask you 1 mark, 2 mark, 3 mark, case based question and long answers also. So We are going to learn in detail hydration of alkenes, Grignard's reagent reactions, dehydration of alcohol's mechanism, dehydration of alcohol at 413 to form ether, and reaction of ethers with HI. All these mechanisms you are going to learn compulsory. They ask you for 3 marks, directly you can write. I will explain you step by step. Okay, step by step I am going to explain you, don't worry. Okay, let's start the video. The first one is classification. Very important, correct? Easy also. First I'll show you classification, then we will go to the examples. Few things I'll make it simpler, few things I'm going to show you a PDF also, I'll show you that. Let us start. First thing, whenever we take classification of alcohols, see carefully students, there are questions asked based on this classification, so please be careful. First of all, alcohols based classification based on sp3 carbon hydrogen bond, first thing. Then containing sp2 carbon OH bond, carbon OH bond, carbon OH bond, careful. Then phenols, aromatic ring, that also sp2. Then classification of ethers based on simple, that is symmetric, and mixed unsymmetric. You see, so only 2 things, not compared to haloalkanes. This is easier actually. Okay, so based on sp3 hybridization, sp3 means what? All single bonds. Careful students, sp3 means all single bonds are there, single bonds. When it is sp2, you have your double bonds. That is what you have to remember. But benzylic is also one more category, but here what happened, you have your CH2, that's why you have your sp3 hybridization, all single bonds. So there under sp3 you have primary, where you have 2 hydrogens attached to OH bond. You have secondary, where there is 1 hydrogen attached to OH bond. Tertiary, where there are no hydrogens attached to OH bond, no hydrogens. Benzylic is something where there is a CH2 group attached, and which is sp3 hybridized carbon, because all single bonds, and you have a benzyl ring. That means it is C6H5 CH2OH. This is your benzylic. Okay, then you have your sp2 hybridized bond, that is, one is vinylic. Careful. In vinylic, what is vinylic? Means you have an OH bond attached to a carbon which is attached to a double bond. This is important. When it is double bond, what? You have sp2 hybridization. Vinylic means OH is attached to sp2 hybridized carbon, that too it is attached directly, yes, to a carbon which is attached double bond. This one, this don't forget students, whenever you see this formation, it is nothing but vinylic bond. Okay, sorry, now this not OH, this is vinylic bond, this is vinylic. So 1, 2, 3, 4. Now comes your phenols. Phenols, it is attached to OH bond, sp2 hybridization. That's in your direct. So in alcohols you have sp3, sp2, and again phenols, and last is ethers. Ethers are those which have symmetrical. Symmetrical means equal. See here, on either side, ether functional group is O, right? On either side you have equal number of carbon atoms. Unsymmetrical, where you have uneven number of carbon atoms. This side you have 2 and this side it is 1. So uneven number of carbon atoms around oxygen is nothing but your unsymmetrical alkene. Okay, right. Now let us solve the first question. Careful, whatever I have taught, now you'll answer me. In benzyl alcohol, OH group directly attached to what? In benzyl alcohol, they said. So draw the structure of benzyl. Just now we studied benzyl alcohol is CH2OH. Correct? Now you tell me, all are single bonds. If I expand this looks something like this. You have, I open the ring, I have carbon, I have hydrogen, I have OH. All are single bonds. So what type of hybridization is this? It is sp3 hybridized carbon atom. Simple observation, that's all. Gradually let us go to one more question. Little bit difficult, we'll go. Next, which of the following shows structure of allylic alcohol? Okay, allylic. Oh, now vinylic ma'am, allylic ma'am, what is the difference? I should know the difference, correct now? Okay, let us make vinyl and allyl so that you will not get confused. Vinylic alcohol and allylic alcohol. Allylic alcohol. Okay, carefully we will understand this. Vinylic alcohol means you have CH2 single as a double bond CH and OH. So you understood this? In vinylic alcohol, what is it attached to? In vinyl alcohol, the hybridization of this particular thing is sp2. Correct na? Sorry. Vinylic, the hybridization is sp2. Now what is allylic alcohol? In allylic alcohol, careful. Whatever in vinylic sp2 hybridized carbon is there, no? In allylic, you have double bond CH, single bond CH2OH. Now what happened here? There is a CH2 bond which has all single bonds here. That's why in allylic it is sp3 hybridized alcohol. Vinylic is directly attached, allylic is indirectly attached. Now which of the following structures shows allylic they are asking? Now observe, see here. This one, na? First one, this is allylic. Easy? Easy. That's all they asked you to mark. So which is sp3. So wherever there is sp3, observe it is allylic and mark it. So which option is correct here? The option, all are correct. Chalo. This is one compound. Here what do you have? Now tell me. CH2 CHOH. Is it right? Is it right? No, it is directly attached. So no. Careful, not. This is not. Then here CH3. Okay, OH is attached to CH3. All single bonds. Yes, correct. Now fourth, OH is attached to CH3, CH3, all single bonds, correct. Means option 1, 3 and 4. So option A is correct in nature. Clear? Chalo. Next question. Let's go to the next question. Which of the following structures hydroxyl group is attached to sp2 hybridized carbon? Oh, here maximum students get confused, but easy. We will do one. We'll take one and explain each other. So this compound, this molecule. So when I take the first one, do I have place? Okay, I will use the first one here. So benzyl alcohol. In this case, when I see all are hydrogen atoms, and because of this hydrogen atoms, what is this? This is sp3. They asked me to find out sp2 now. So this is sp3 ruled out. Let us take the next one, B1. Let us take the B1. B. In this, the structure was looking like this. You have your CH, you have your OH, and you have your OH. Now what happened? Do you have any double bonds here? No. This is also sp3 ruled out. Third one, they asked me to find out. Next, what is the structure? Okay. They asked me to find out for this molecule OH and CH3. Now tell me, in this OH and CH3, are there any double bonds, single bonds? Yes. Yes. See here. This is here. This looks nothing but it is your. It's like this, na? It's like this here. Now your OH is attached to double bond. That's why this hybridization, this is nothing but paracresol, no? Yes, for 4-methyl phenol. So this has a double bond, that means this is sp2. D part, you have your structure which is nothing but that is 1-phenyl 2-propane, na? That is what I observed. 1-phenyl, yes, 1-phenyl 2-propane. So CH3, this is your OH. Now you tell me, in this case, OH is attached to a side chain which is CH3 group. That means this is sp3. That's all over clarity we got. So the answer for this is option C, which is nothing but double bond. So the answer is option C. Remaining all are sp3s. Chalo. Next question. This is a blank page. I am shifting to the next one. Blank. Okay, chalo. Next nomenclature is what we are going to learn. Careful. Now let's start with the next question. That's nothing but your IUPAC nomenclature. Alright. So this is a molecule which is given. I very well know this is an ether functional group because oxygen is there in this. Now how to start numbering it? Start numbering it with the longest chain. Okay. Now this is the main parent chain and this is your substituent. We very well know if it is not written, it means it is methyl group. So how will I name it? It is prop. Correct na? 3 carbon chain. So here I will write it is 2-methoxy because 2-methoxy, second position you have oxygen in the methyl group and propane. That is the correct combination. So the option C is right. Look at the longest chain. Careful. One more question we will see. Let us see this. The IUPAC name of the following compound. Okay. There are two alcohol groups. There is one alkene group. Careful. How to start numbering it. Let's start from this terminal. 1, 2, 3, 4, 5. The parent chain is pent. And there is one substituent at the third carbon. So what is this compound? It is 3-methyl, okay, 3-methyl pent 2-ene 1,2-diol. Yes, 3-methyl pent 2-ene. See this, I have numbered it na. 3-methyl pent 2-ene 1,2-diol. You are able to see how I am numbering the molecule. Yes, careful while numbering. Look at the functional group, start from there and do it. Next question. Write the IUPAC name of the following compound. Again you have OH group. Again there is a substituent CH3 group. Here also there is a substituent 3H3 group. I have to first number the carbon atom. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Correct na? So where you have your methyl group, start from methyl 2,5 comma dimethyl. Okay, then hexane 1,3 diol, because there are two alkyl group, two alcoholic functional groups in this. Easy? Very easy. Next question. Write the IUPAC name of this compound. It's a cyclo compound. There is no aromatic ring. So both, if you see, this is an ether functional group. Correct na? So how should I start numbering? I have to start numbering from here, looking into the O position and taking into consideration 3, 4, 5 and 6. What is the name of this compound? 1-ethoxy 2-nitro, then cyclohexane. 1-ethoxy 2-nitrocyclohexane. Easy? Very easy. Very easy? Chalo. Next question. Very important. Let's go gradually. The IUPAC name of the below compound. Okay. IUPAC name of the below compound. They have given this. They have given two functional groups. They have elaborated the structure. It's easy. Let's start numbering it. So first of all, how do you number? From where should I number, ma'am? Careful. Always check with the functional groups. Always check with the functional groups. So here, longest chain I need to check. Okay, 1, 2, 3, 4, 5. All right. Then I'll start numbering from here. Suppose if I start numbering from here, 1, 2, 3, 4, 5. Here also pent I'm getting, but 2 and 4. Okay, diol. Then 2-methyl. No, methyl group should come first na. Methyl group as a substituent should come first. So I'll number it from 1, 2, 3, 4 and here 5. So what is the name of this compound, students? It is 2-methyl 2,4 pent and pentane diol. 2-methyl 2,4 pentan diol. Easy? Very easy. Chalo. Next question. Vinyl carbonyl is what? Vinyl carbonyl. Okay. Vinyl carbonyl, as I said, first of all, vinyl means sp2 hybridization or sp3 hybridization. Careful. Tell me. Understand carefully. So basically, vinyl is something where it is attached to the carbon atom and then attached to your double bond. Correct? That is what we have seen. Vinyl means it is attached to OH group, is attached to a carbon atom which is attached to a double bond. Correct? Right? So now in among all this, if I have to expand and see, now can you tell me which molecule is vinylic carbonyl in this? Will you tell me in the comment section? I am waiting for your answer because I want to see how students are concentrating in this. So if you tell me in the comment section which molecule is this, which is the option, so comment or tell me option, answer, what is the option in this? Tell me in the comment section. Your answer will be pinned. Comment section answer will be pinned. I'll pin the answer so that I'll say yes, the student has answered it correctly. Okay, let's see this simple question only, students. Easy. Let us go to the next topic. Preparation of alcohols, phenols and ethers. Ma'am, so much is enough. Yes, I'll be sending a worksheet to your telegram also. Careful, you're going to understand the worksheet and you can start solving the question also, so that further you will be clear of the questions. Okay, preparation of alcohols, phenols and ethers. So basically what preparations, alcohols, I can prepare alcohols from. First one, the first preparation is from alkenes. I can prepare alcohols from alkenes. What is the name of this compound? It is nothing but acid-catalyzed hydration. Careful, preparations, that is also called as acid-catalyzed hydration. Very, very important reaction. It's a mechanism which is there. They will ask you. Okay, what actually is this? Simple. Acid-catalyzed hydration is nothing but the conversion of alkenes. You're converting to your secondary alcohols. What are you doing? You're converting alkenes to secondary alcohols, and that too, which one? By using Markovnikov addition. Mark addition. You're doing Markovnikov addition and you're converting alkenes to secondary alcohols. Ma'am, I didn't understand this. You will understand carefully. Let us take an alkene. Now, this alkene is an unsymmetrical alkene. What is the name of this compound? This is propene. I am adding water. Hydration means what? Water. In what presence I am adding? In the presence of acidic medium. I am maintaining an acidic medium. So in Mark addition, you very well know, if I break this, the negative addendum goes, and even the bond breaks here, na? Then the negative addendum goes and adds to the carbon having less number of hydrogens. Correct, na? The negative addendum goes and adds to the carbon having less number of hydrogens. Correct? Now this is 2, right? This is 2. Okay, less number of hydrogens. 2, 3, 4. So here 1 hydrogen, here 2 hydrogen. So what do I get? I get this molecule. I get hydrogen. Correct, na? Negative addendum. So this is what molecule? This is propan 2-ol. So is it not secondary? It is secondary molecule. Correct, na? Yes. So what is the mechanism for this? How do I understand the mechanism for this? Simple. First step or step 1 of this mechanism, I am going to take the alkene. Okay, I am going to take the alkene, unsymmetrical alkene. Now there is a pair of electron here. Correct, na? Double bond. Now what will happen? One H plus comes and attacks this. So this electron pair is shared by this H proton. Then what do I get? I get this is losing the electrons, na? So this becomes a carbocation, secondary carbocation, and your CH2 is attached to this. Is it okay? Easy? Easy? Very easy. Now anything, there are 2 things formed. Either it may I'll show you the second one. This one, it's going to form a molecule, yeah, in this way. But among these 2, this is primary, this is secondary. Which is more stable? Secondary is more stable. So this product is more preferred. Secondary is more stable. So the secondary product is preferred. Then step 2, what will happen in step 2? In step 2, the same molecule, whatever is there, that is secondary carbocation, because secondary products we are getting now. So what will happen? The water molecule with a pair of electrons is going to come and attack, because hydration, because I have to add water, it comes and attacks this secondary. That secondary carbocation, what will happen? You have your H, along with that your water molecule will come and attack this, because water attached and your CH3 is out, means it's joined outside. Any doubt in step 1 and step 2? First attack of H plus ion, second attack of water. Okay, right. Now step 3, I have to, okay, there's no place here. Step 3, I'm sorry, I will make it here only. Step 3 is the molecule, whatever is there, the proton, whatever is there, this proton comes out and no, once again, here OH minus, it has shared the electron pair, no? So this will become positive now. Oxygen oxonium ion, it will become positive, and from here I'm writing it here, sorry students, the place is less, minus H plus ion comes out and you are getting your secondary alcohol. Is it okay? Yes. Step 1, step 2 and step 3. First proton attacking, then formation of secondary carbocation, second water is attacking, formation of oxonium ion, third removed of H plus, then forming the secondary alcohol. That means first high proton is added, then water is added, then high proton is removed. That's all is alkene. Easy. Let us see one question. Acid-catalyzed hydration of alkenes except ethene leads to the formation of what? Oh, they're asking acid-catalyzed hydration of alkenes except ethene leads to what? Now we will see one after the other. Primary alcohol. Okay. First of all, primary alcohol, what happens when I do? Okay, let me take one primary alcohol. You know what is the concept of acid-catalyzed hydration? Primary alcohol. Yes. So primary alcohol, except ethene, only ethene forms primary alcohol, correct na? Yes, only ethene. So only remaining all. Then this ethene, I am adding water, I am adding H plus ion. So the bond breaks, Marconic of addition. So I will get CH2H. Okay, symmetrical. Now they said ethene is excluded, except ethene is excluded. So this option I am not considering at all. Next option, secondary or tertiary alcohols, they said. Now let us take one secondary alcohol. What is secondary alcohol? Secondary alcohol, basically I'll make propan 2-ol. Okay, secondary alcohol, I'll make it as propan 2-ol. Now what is propan 2-ol? This is your molecule. This is your, okay. Secondary alcohol I should prepare now. Okay. From secondary alcohol means I take propene. Then I will add water to this. Then H plus. What will happen? It goes and breaks. Negative addendum mark addition will happen. You will be getting secondary alcohol. OH and CH3. Done. Okay. Now tertiary alcohol is what I have to see. Secondary is over. This option is over. This option is over. Tertiary alcohol I have to do. Okay. Now I am taking tertiary alcohol. Third one, I am taking one tertiary alcohol. Okay. In tertiary alcohol, what example I am taking? I am taking one 2-methyl 2-propan. How do I remember all this? See this. You can draw a tertiary alcohols here. 1. To this carbon I am adding CH3. To this carbon I am adding CH3. Okay. To this carbon double bond alkene. This one alkene. See here. This is tertiary na. Now to this I am adding water. Then again the bond breaks. No. When the bond breaks, what happens? This particular thing. This bond breaks and I get tertiary alcohol. They asked no. I got OH. This is added. The bond breaks and OH is added to this. And yes, CH2 group is added to this. Okay, over. So now this molecule, what happened? Mixture of, and then what did they say? Secondary is over, tertiary is over. This is also over. Now what is the next thing? Mixture of primary and secondary alcohols. Third option we will check. This is what option? Okay, third option. Option 3. Now this also comes under second option only. No, option 3. Primary alcohols and secondary alcohols. Now only primary alcohol which we have is ethene. Na? Primary alcohol, only thing which we have is ethene. Does it form ethene? It doesn't form acid-catalyzed hydration. So hence this option is completely wrong. The fourth option what we have is, they said mixture of secondary and tertiary alcohols. They said mixture of secondary and tertiary alcohols. Correct na? So mixture of secondary and tertiary alcohols means, you only tell me what will we take? Any alkenes, rather like 1 second. Yes. Secondary and tertiary alcohol. Okay, let me take one example. I'm taking an example of butane. Okay, butane. What does it form? When I do acid-catalyzed hydration, it will become butan-2-ol. Correct na? Butan-2-ol. This is a secondary alcohol. Correct na? Then when I do one more I'll take tertiary, that is same butane. When I do this one, I get two different products. One is butan-2-ol and 2-methyl-propan-2-ol. How do you know this? I'll show you the reaction. You will understand the reaction and see. This is tertiary. Okay, let us see. First one, I will take butane. First, I will take butene. I will add water to this in the presence of H plus ion. Okay, now what molecule you get? You get two different molecules. First molecule is one. This is butan-2-ol. Along with this, you get one more molecule attacking the double bond there. Same thing. Either it is adding here, or it's adding the other way around. Two molecules you get. So that means, what did they ask? They said, now this is clear, right? Before we go to the next thing, you understood, right? What did we write first of all, before we go to this question? We said one thing, question, acid-catalyzed hydration of alkenes except ethene leads to the formation of. So what option do I get now? What answer will I get? So I have to tell the examiner, acid-catalyzed hydration of alkenes except ethene will be given, or that means the most generally it will be given mixture of secondary and tertiary. That is what, see here na, correct na? So primary is ruled out, that option. Only secondary or tertiary mixture, yes, secondary or tertiary. Now secondary or tertiary, this is also ruled out. Primary is anyhow ruled out. So secondary or tertiary, as I showed, they form mixture of compounds. Yes, let us take a small break and then again come back. Next we are going to see hydroboration-oxidation reaction. Hydroboration-oxidation reaction. Okay, right, then we will come back soon. Alright, now let's start learning and understanding hydroboration-oxidation method. Now simple. In acid-catalyzed hydration, what did we learn? Acid-catalyzed hydration, or basically alkenes are converted to secondary alcohols. Correct? Now this is what we have studied. Now in hydroboration-oxidation reactions, simple. Alkenes are converted to primary alcohols. Don't get confused. It's easy actually. Okay. Now hydroboration-oxidation reaction. What are required? Basically, I require an unsymmetrical alkene. It's almost, whenever you see an alkene, na, it's like it's the same addition, either mark addition or anti-marconic of addition. Careful. Now here we are going to take diborane. Alright, diborane. So basically diborane, you can also write it as BH3 taken twice. B2H6, simple molecule. So this BHC, this BH3 I can divide into H and BH2, correct na? Same thing I can divide. So what will it do? It's going to break the bond and simple the negative, here what happens? The hydrogen goes and adds to this and your BH2 goes. Ma'am, the negative addendum goes and adds to the carbon having, yes, you have understood that. Now what is happening? Negative addendum is going and adding to the carbon having more number of hydrogens. Yes, that's why this is an anti-marconic of addition. It is happening in the presence of peroxide. Okay, so this is, you will be getting an anti-marc product. Careful. Here it was marconic of addition. Now here it is anti-marconic of addition, where you are going to take out or replace this pH2 and you will be getting a OH group. That is nothing but a primary alcohol. That means indirectly this is nothing but CH3, CH2, CH2OH. This is nothing but your propanol. Correct na? Propanol is nothing but your primary alcohol. Easy? Very easy. So hydroboration-oxidation reactions are producing primary alcohols following anti-mark addition. This is mark addition, this is anti-mark addition. Okay? Let us see a question now. Hydroboration-oxidation reaction of this. Yes, this is unsymmetrical alkene. Compulsory, easy. I very well said hydroboration-oxidation reaction converts alkenes, that is unsymmetrical, to primary alcohols. Correct now? Now what is this molecule? This is your propene. Compulsory you will be getting propanol or propanol, one alcohol, propanol. Correct? Now where is your propanol here? In all the cases this is primary, this is secondary. So easy. Once you see the structure, you can easily do it, right? So basically the correct option is option 1. So propan 1-ol, this is the option. If you still want the reaction, I will do it for you. This is your molecule. Correct? Now what are you adding? B2H6 or BH3 taken twice, or you'll be adding H and you'll be adding BH2. Correct? Now what will happen? The same molecule, as I said, break the bond here, H, this is your H, double bond CH2 BH. Now single bond, this becomes your single bond and bond breaks. Correct now? So then your hydrolysis happens to this reaction. Water molecule OH minus. This is an oxidation reaction, that to Marconic of anti-mark addition. Then this your molecule breaks, your molecule goes out. Sorry, this goes out and you will be getting CH3, CH2, CH2OH, that is propan 1-ol. Easy? Option easy. Now in this is one more preparation after hydroboration. This is from the carbonyl compound, students. So earlier what did we study? We have studied acid-catalyzed hydration, we have studied hydroboration-oxidation. So before we go, we'll once summarize. First one is your, one second students. Okay, first variety is we have used acid-catalyzed hydration. In acid-catalyzed hydration, what did I get? I converted alkenes to secondary alcohols using mark addition. In second category, in hydroboration-oxidation reactions, I will be converting alkenes to primary alcohols using anti-mark addition. Okay, done. Now this is the third variety, where you will be getting we'll be getting your basic from carbonyl compounds or carbonyl molecules. So here we'll be converting aldehydes, we'll be basically reducing aldehydes, we'll be reducing acids, we'll be doing it one after the other. I'll explain in detail first for the general understanding. So careful, we have different reducing agents. This is where you should remember. Aldehydes or esters or acids are converted or reduced using different reducing agents like palladium, sodium borohydride, lithium aluminum hydride, in that way. Okay, so what to remember is aldehydes when they are reduced. First thing, your understanding seeing this, aldehydes when they are reduced, they are getting converted to what? They are getting converted to alcohols. Correct na? Yes, right. Next, ketones when they are getting reduced, they are getting converted to secondary alcohols. This is your primary alcohol, this is your secondary alcohol. Correct na? Ketones. Now, next, acids, when they are reduced, they are again getting converted to primary alcohols. They are converted to primary alcohols. Now, further acids, again more and more. If esters are there, if they are reduced, they are also getting converted to alcohols. That means, what should I understand? Reducing agents are important, products are important. Now, I'll explain in detail what it is. So, basically, first concept is, I can use for a reduction of carbonyl compound different reducing agents. What are the different reducing agents I can use? I can use NaBH4, sodium borohydride. I can use lithium aluminium hydride. I can use hydrogen with palladium. I can use these. This one is specific for aldehyde and ketone. Means I can use it for aldehydes and ketones. Lithium aluminium hydride, I can use it for ketones. I can use it for aldehydes. I can use it for acids. Remember this. Careful. Okay. This is only for these two. This one can be used for all the three. Okay. Now, let us understand. First, I am taking formaldehyde. Now, any type of aldehyde gives me alcohols. Reduction. This is formaldehyde. Then little carbon chain I am increasing. I am taking acetaldehyde. A little going further, I am taking ketones. Okay. Now, what am I introducing? What reagents? I said now for aldehydes and ketones, I can use sodium borohydride. Now, first thing, reduction. What is reduction? Addition of hydrogen. Correct na? Reduction is addition of hydrogen. Anywhere, wherever you are going, you are adding hydrogen around the double bond and carbon. Now, simple, see here, shift, shift, shift. Now, your one hydrogen is added here, one more hydrogen here. That's all. Same thing. One hydrogen is added here, one more hydrogen is added here. Same thing. One hydrogen is added here and one more is added here. Now, name this compound. This is formaldehyde. Correct na? So, you are adding OH to this. This is acetaldehyde. You are preparing your, here also primary alcohol. Here also primary alcohol only. Here you are preparing secondary alcohol. Just what did you do? You just added hydrogen around the oxygen and the carbon. The center one concentrate and add it. Easy? Easy. Next, after your aldehydes and ketones, next thing are acids. Now we will be doing the reduction of acid. What did I say? Acids whenever you are using. Yes. And here, you can also use it for esters also. Esters also you can use this. This works. Now, whenever you are reducing, I am using a reducing agent, lithium aluminium hydride. Easy. You are taking an acid. Always your concentration should be around oxygen atom. Yes. No. Reduction means addition of hydrogen. Correct. Where should you add? Around your oxygen atom. Simple. Same carbon you will add. You take carbon, oxygen, oxygen and this. Now, ma'am, what is this molecule? Is it right? Correct? Did I read right? Something is wrong, na? Yes, this is the wrong product what we did. So, reduction is, careful students, addition of hydrogen and removal of oxygen atom. In case of acids, you will be doing both. How will the product come? Now, this oxygen is gone, hydrogen is added. So, carbon, hydrogen and oxygen. So, this is nothing but CH3, CH2OH. This is your primary alcohol. Easy? Easy, very easy. Now, we will do with one more. I have place in the next one. Yes, I have place. I'll do this. I am going to take an acid. Now, I am going to do a reaction. That's nothing but esterification reaction, where an acid and an alcohol are combining together. This is a grade 10th reaction, esterification. Acid is combining with an alcohol. In the presence of what? In the presence of acidic medium, H plus ions of sulfuric acid. Water is removed from here, and what do you get? I'll be getting COOCH3. This is an ester group, correct na? Yes. Now to this ester I am using palladium one reducing agent. So what will happen? The oxygen is removed, hydrogen is added. So you will be getting a primary alcohol plus methanol. So basically the bond is broken. If I have to say, the bond here is broken in this direction. CH2OH, OH is added and H is added. That's all. So it will break into. Now whatever we did till now, okay, the last one is a Grignard. So we will take a short break and then come back. Okay, so we did from what? We did from aldehydes reduction, ketones reduction, esters reduction. So once we'll summarize, aldehydes on, or the acetaldehyde, they'll give me primary alcohols, ketones will give me secondary alcohols, esters also will give me primary alcohols. Here what reagents are suitable for this? Sodium borohydride I can pick, correct na? For this also I can pick sodium borohydride, but if you want lithium aluminum hydride, I can use it for ketones, aldehydes, acids and esters also, correct na? This is specific for these. Remaining all, even if you take aldehydes, esters, acids also, when you do acids produce esters, I can, for all put together, I can use lithium aluminum hydride. Okay, we'll take a short break and come back. Alright, now let's start third preparation. First was acid-catalyzed hydration, then next was your hydroboration-oxidation, then we did reduction process. Now third one is Grignards. So basically this is an overall summary of your Grignards. First understand what products are there. So basically Grignard's reagent, careful students, you are going to use, careful, it can be your aldehyde group or it can be a ketonic group. That's first thing you should understand. Grignard's reagent can react with an aldehyde or ketone to form water. So basically whenever your primary alcohols, so understanding of the concept is important. Carefully understand what it is. So Grignard's reagent, first of all you are going to break the carbonyl, carbon, oxygen rather, into water. Electron density of oxygen is more than carbon. When it drags, it gets a partial negative charge rather. When it's pulling, it gets a partial negative charge. And this gets a partial positive charge. Correct na? Now, same thing in the Grignard's reagent. The alkyl group is electron rich. So it gets the partial negative charge and this whole molecule gets the partial positive charge. Easy. Negative goes and attacks the carbon atom. Positive goes and attacks the negative atom, correct na? Concept is this. So you will be getting an adduct. You will be getting an adduct where oxygen and magnesium are bonded and the carbon is bonded with the electron rich carbon atom. Then further on hydrolysis, there is a cleavage of the bond here. Yes, even water molecule H plus and OH minus, and you will be getting this compound. So the particular thing, basically your alcohol is formed, whether it is secondary alcohol, primary alcohol or tertiary alcohol. So this summary will be useful for your questions on the MCQs. Now we will understand in detail what it is. Okay, chalo, let us understand carefully. First, what is the reaction? I am going to take the Grignard's reagent reaction, means basically I am going to take an carbonyl group. Okay, let this be. This is partially negative, this is partially positive. Now Grignard's reagent is reacting with this. This is partially negative, this is partially positive. So the negative adenine goes and attacks the carbon and the positive goes and attacks the oxygen. This bond shifts. So what happens? You will be getting a adduct, right? This is minus, this is plus, and carbon is with alkyl group and R is here. The further you're doing hydrolysis and the bond breaks, OH group, and your R group plus MgOHX. That's all. This is your concept. Now same thing, R may change, this R may change. Okay, you're going to take that. First of all, whenever you're taking formaldehyde, I have placed here, I'll be using that before we go to the phenols preparation. Aldehydes, I'm taking formaldehyde is what I'm taking. Same procedure. Step 1, shift. Step 2, mark. Step 3, again mark. Step 4, careful, this gets partial positive charge. So alkyl comes and attacks here, magnesium goes and attacks here. So what will happen? Same procedures. OMgBr. Here CH3, then H. Then your hydrolysis you're doing, there's a bond cleavage and you'll be getting OH, CH3, H, and your MgOHBr is out. What is this molecule? What is this compound? This is nothing but, if I have to write, this molecule is nothing but CH3, CH2OH, nothing but your primary alcohol. So the conclusion of the story, formaldehyde with Grignard's reagent forms primary alcohol. This you should remember. Yes, it's compulsory. You will compulsorily get this. Careful. Okay. Question number 1. Next thing, second one. Now acetaldehyde, double bond OH, again CH3 MgBr. Same procedure. Bond shift, negative charge, positive charge, negative charge, positive charge. Same molecule shifts here. It's the same procedure, students. What do you get? You will be getting CO MgBr, then your CH3. Further you're doing hydrolysis, the bond breaks, so you'll get CH3COMg, CH3, this is already broken now, the bond OH, and your CH3, and this plus MgOHBr. So what is the molecule now? Acetaldehyde with Grignard's reagent is going to give you secondary alcohol. Now third one, ketones. So I'm taking ketones, same procedure, and I take CH3 MgBr, same procedure, shift, you get CH3CO MgBr. This is also CH3, this is CH3, and on hydrolysis you will be getting tertiary alcohol. That's all. Easy? Very easy. Tertiary alcohol, this is your molecule. That means ketones with Grignard's reagent are giving tertiary alcohols. Easy? Very easy. That means what should you understand before we go to the preparations? We'll summarize once. What did we summarize? Whenever you're taking in Grignard's reagent, shall we go back and summarize? We have place here. Yes, we will write here. We said, careful, primary alcohol, you have to take methanol, formaldehyde. If you want secondary alcohols, you will be taking aldehydes, anything like, acetaldehyde, anything, propanaldehyde or butanaldehyde, you can take anything. For tertiary alcohols, you need ketones with appropriate Grignard's reagent. So I'm summarizing. If you want primary alcohol, compulsory, you will be taking methanol. If you want secondary alcohol, you can take any aldehyde other than methanol. Any aldehyde other than methanol is not taken. Other than methanol. If you want tertiary alcohols, you will be taking ketones. Okay, chalo. This is your summary. So before we go into your phenols, preparations of aldehydes, once we will summarize again for you all. First, Acid-catalyzed hydration converts alkenes to secondary. Hydroboration-oxidation reaction sorry students, alkenes to primary alcohols. Reduction. In reduction, what do you get? Your aldehydes, we summarize now. Aldehydes will get converted to primary alcohols, correct? Then ketones will get converted to secondary alcohols, correct? Then esters also will get converted to primary alcohols, correct? And fourth one, from Grignard's reagent, we said just now, methanol will give primary alcohols. Any other aldehyde other than methanol, any aldehyde will give me secondary alcohols, and your ketones will give me tertiary alcohols. Is it okay? Done? Now let's meet again with preparation of phenols. Carefully we will do. Yes, I'll meet again. Just I'll drink water and come back. Alright, so students, we have already done the Grignard's reagent. I also summarized it, so I went back again little bit. So after Grignard's, let us solve some questions based on the preparations of your alcohols. So let us see one question, understand it, then go to the preparations again. Alright, I added few slides to this. Alright, let us see. The alkene RCH double bond CH2 reacts readily with B2H6. Okay, this question is basically based on your hydroboration-oxidation reaction. Hydroboration reaction, right? So hydroboration-oxidation reaction, what should I understand always? It is, I have to remember that alkene is going to get converted to your primary alcohol. This is what is your concept. Okay. So the alkene readily reacts with B2H6, and the product on oxidation with alkaline hydrogen peroxide produces what? Simple, students. If I have to tell you in simple words, remember how many carbons are here? Yes. So exactly whatever reactant is given to you, only difference is other than alkene, an OH group will be added. Okay, we will solve it, but understand, other than this alkene, an OH group will be added here at this terminal carbon. So what is the thing which is present here? Same number of carbon atoms, 1, 2, 3 are there. What is there? 1, 2, 3. Okay, 1, 2, 3. Yeah. This is what is the answer. How many are there? 3 are there. So only thing is terminal carbon has an oxygen hydroxyl group because it is primary alcohol. Now let us solve the question. And let us see, before we go to this question, understand how it is. So in the exam, remember, given alkene is converted to primary alcohol. That's all. So what is this? Now I'm going to take your group. Okay, let me solve and show you. Okay, now the alkene readily reacts with this. Okay, so what did we do? We have added B2H6 to this. B2H6. Okay, ether is present as a solvent at the temperature of 0 degrees centigrade. Now this bond breaks, and what do I get? So now how many diborans? 2 are there. So to balance this, I will take 6 alkenes. So I'll be getting RCH2. Careful, CH2 taken twice. I did it earlier also, and your diboran means I substituted 6 times. I took na. So B2H6, I directly wrote the product breaking. Instead of writing here, what did I do? I did step by step in the earlier slide. Here directly I took it, and how many ever diborans are there? 2 diborans are replacing, and I got the bond there. Is it okay? Yes, directly. Okay, no problem, not required. Then hydrogen peroxide I took in the presence of sodium hydroxide. So anti-mark addition, which produces primary alcohol, the same number CH2OH, primary alcohol, along with your boric acid H3BO3. If I have to balance, this becomes 3 2s are okay, and this becomes 2. Okay, done. So careful in MCQs when they say, remember whatever alkene you get, the same alkene with a terminal OH group is your answer. Clear? Everybody clear? Alright, next question. Identify Z in the sequence of the following reactions. They have to identify what is Z. This is what they said. Now first of all, what is this reaction? it is HBr. Okay, in the presence of peroxide, compulsory this reaction is an anti-Markovnikov anti-Mark addition or peroxide effect. Peroxide effect is a reaction. I should remember in peroxide effect what will happen. In peroxide, alkene gets converted, or it is going to form which alcohol? Careful students. Now primary, but here alcohol they are not talking. They have given me ether combination, so I will not talk about ethene alcohol. Will directly solve it. Okay, so anti-Mark addition, that is what. So I have to check what ethene is getting converted to. Okay, no problem. Leave it. Now, what is sodium ethoxide doing here? It is going to form, sodium ethoxide is the best reagent for producing what? Producing ethers. Sodium ethoxide produces ethers, means it acts as a solvent to produce ethers. That's the best thing. Now, taking into consideration, let us start. First of all, what will I do? Do I have place next page? I don't have place. I will solve it here. Okay. First, I am going to take this alkene. Okay. Then what will happen? In your peroxide, that is anti-Mark addition, H2O2, the bond breaks. Careful. The negative addendum, positive addendum, careful students. So careful, the negative addendum goes and adds to the carbon having more number of hydrogens. Positive goes and adds to the carbon having less number of hydrogens. It is the other way around for Mark, right? So I am going to add those across this bond. This is okay. What is this? This is 1-bromobutane. Okay, now what did I do? I added ethoxide, C2H5ONA. I said na, your Na and you're heating it. Then your Na will go and attack and remove this Br, and this chain goes and attaches to this. How does this attach? Now check carefully. Your this bond is right there, right? Your CH2 taken twice, exactly. The bond breaks here, and you are going to get CH3, CH2 taken thrice. Okay, O, then CH2, then now your C2H5 is there, no? So this whole thing basically, no, 1 second students, this bond doesn't break here. I'm sorry, the bond breaks here. I'm sorry students, NaBr has to come out now. The bond breaks here. So 1, 2, 3 CH2s have written, oxygen, and your CH2 CH3, or nothing but your CH3 CH2 taken thrice, O, C2H5. Got it students? So easy. The bond exactly breaks at bromine. So what are you getting? You're getting an ether. Now what is this option given to me? The option given to me is your A option. A option, correct na? Yes, simple. So alkene here is getting converted to your, first if I have to say, anti-Mark addition has happened. It's forming primary alkyl halide. Then primary alkyl halide, 1 degree alkyl halide is getting converted to ether in the presence of ethoxides, C2H5ON. That's all. Easy, 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 very easy. Next question. The missing reagent X in the following reaction is what? Missing reagent. Now what did they give? Okay. Missing reagent is the reactant is missing. I have to find. First of all, what is this reagent? H2, and in the presence of nickel. Yes, it is a reducing agent. Correct na? Nickel, platinum, palladium, lithium aluminum hydride, all these, sodium borohydride, all these are reducing agents. Okay, what is the son of this? The reducing agents are going to add hydrogen or remove oxygen, or add oxygen or remove hydrogen. The reduction means it is going to, careful, it is going to add hydrogen to that. Okay, right. Now same compound, this let us assume this compound has added hydrogen. This hydrogen and this hydrogen is added already. Okay, so take out this hydrogen, take out this and take out this. What product do you get? Go back, you get CH3 CH2 CHO, correct na? CHO. That's all, simple. Just it is added. Simple. See here, I am adding H2, nickel, hydrogen is added to this. So what is the name of this compound? It is nothing but propanaldehyde, correct? And I am adding hydrogen. So what will happen? The same, one hydrogen and one hydrogen adds. Is it easy? So oxygen, like concept is simple students. CH3, CH2, CH2OH. How do I remember this? How will I get this? Like concept wise, how will I? Because it has added hydrogen to both, and suddenly, ma'am, how do I remember? I'll give you a simple clue. Just remember this, and you in the exam it's easy. Always, whenever concept of reduction is spoken, or whenever somebody talks to you about reduction of carbonyl compounds, note this important thing, students. Reduction of carbonyl compounds concept, very, very important. In chemistry, concept is important. What is that concept? Careful. Point number 1. Aldehydes on reduction, they give me primary alcohols. Always remember. See this. Go back. See here. Aldehydes on reduction gives me primary alcohols. Easy. Here, what reagents you're using? You can use reducing agents like lithium aluminium hydride, sodium borohydride, and hydrogen and palladium. You can use these. Remember this. Second thing, ketones. Ketones on reduction. Yes, they are going to give me secondary alcohols. What will I use? Reducing agents. For example, lithium aluminium hydride, sodium borohydride, and here you can use hydrogen and nickel. Remember. Next, I'll ask you now. Suppose acetone is there. Okay, acetone. What is the secondary alcohol I will get? Isopropanol. Correct? Na? From acetone, I'll get isopropanol. Simple. Only thing is there, instead of the carbonyl group, you are going to add hydrogen. Third one, suppose if I take aldehydes and ketones. Aldehydes and ketones, if I take, there is one reaction, that's nothing but Clemmensen reaction and Wolff-Kishner Clemmensen reduction and Wolff-Kishner reduction. These two are there, Clemmensen and Wolff-Kishner. So in this Clemmensen and Wolff-Kishner reduction, what are you observing? Careful. In basically Clemmensen is going to use a reagent that is zinc amalgam and HCl. Zinc amalgam HCl. And Wolff-Kishner is going to use hydrazine NH2 plus potassium hydroxide, and you're heating it. Okay, this one. In this, what happens? Nothing. Whether aldehydes or ketones are going to convert, or aldehydes and ketones, they get converted to alkanes. Only reagents are different. Okay, remember this. This is a concept. You can apply it anywhere. So, got it? Jump. Next question. Which of the following compounds does not give a primary alcohol on reduction? They do not give a primary alcohol, it seems. Okay. Now, how do I know? Should I test everything and see? They said they've given one reduction. Just now we saw na this one. So you need to take each one and then start solving it in the exam quickly. But one thing you can just understand carefully. Okay, one clue I'll give here. Such questions when you are doing ma'am, it's time consuming. Any other clue to do? Okay, you can use this clue for solving this. It's easy. But anyways, for the students who are watching, I'll do it one after the other for you, so that we will come to one conclusion and understand. First, what did they give me? Propionic acid. Take this. Your propionic acid is here. Okay, C double bond. I'm explaining it for you all. Just see, this is propionic acid. I'm using what? Lithium aluminium hydride as a reducing agent and H3O plus hydronium ion. Then what happens? The oxygen is removed, reduction, and hydrogen is added. H2 is added. So what do I get? CH3, CH2, CH2OH over. Okay, done. Next one. What did they give me next? Propanol is what they've given me. I'm taking this propanol. This is your propanol, correct na? So little bit space, propanol. Now again I'm using the same reducing agent. Remove this oxygen, add hydrogen, correct? Same concept, CH3, CH2, CH2, OH. Okay, right. Now, ma'am, we didn't remove oxygen. Na? Here we already have the oxygen. Okay, so what should we do? We just are adding here. We are just adding one hydrogen to this, correct na? According to this, oxygen is retained. That means we are adding only one hydrogen atom to this, and oxygen is still there only, correct na? Yes. Okay, simple. Next thing, what did they give me? Methyl propanate. This is my methyl and propanoate. This is your COO and ester bond. Same, I'm using the same reagent. Now ester, always in the presence of H3O plus. What will it give? It will give me mixture of alcohols, correct na? This is one alcohol and this is one more alcohol. So you're going to break one hydrogen sorry the bond breaks in this case, and you will be adding 2 hydrogens here. Careful, 2 hydrogens here and here. Okay, so now what do we get? Basically, let us see, 1 hydrogen here, 1 more hydrogen here. Okay, CH2 OH. Okay, so let us add and see. CH3 CH2 CH2 OH. Correct na? First one. Then the second one is CH3OH. Yes. So basically you're getting mixture of 2 more compounds. One is your propanol, primary alcohol, methanol rather, primary alcohol. The last one, D part, I am going to take a ketone. This is your ketone which is given. I have taken the examples. Then again I am using the same reagent. Now what will happen? Your ketone, the reduction, addition of hydrogen, 1 hydrogen here, 1 more hydrogen here, this is 1 hydrogen, and here 1 more hydrogen. Okay, what is this compound? This is propan 2-ol, this is secondary, this is 1 degree, this is primary, this is primary, this is also primary, this is also primary. Over, I did all. Now careful, you only tell me, go back to the question. Which of the following does not give a primary alcohol on reduction? Which one, students? Propan 2-on. See here, all have given me primary. Only this one will not give a primary alcohol. That's it, that it has given. This has given secondary alcohol. Correct na? Okay, understood? Next question. Which of the following reactions will produce a tertiary alcohols? Okay, how do I understand? This is Grignard's reagent question. I give you a clue. Remember this, and easy. Whenever you're using Grignard's reagent, yes, careful. With Grignard's reagent, I have next place. Okay, I will do solution. We will do here. Whenever somebody is talking to you about which of the following, see, they didn't say Grignard's reagent, but they have given all the Grignard's reagent as these are all Grignard's reagents, na? Yes, so careful, always remember, yeah, CH3 MgI, dry ether, alcohol. Okay, so if you want to get primary alcohol, okay, this is the concept, you will take formaldehyde with CH3 MgI. Okay, yes, remember, suppose if you want to get secondary alcohols, what will you do? You see, except formaldehyde, all other, like for example, you know, your CH3CHO or you know C2H5CHO, all except this formaldehyde, if you add CH3 MgI, you will be getting secondary alcohols. Yeah, next, if you want tertiary alcohols, okay, you will be adding ketones. So ketones, CH3 C double bond O, CH3 ketones, and if you are adding CH3 MgI, then you will get tertiary alcohols. So remember this is a concept for your Grignard's reagent, so please use this concept. Once again, students, okay, I'll just silent my phone. Okay, so go back, now see the question. Which of the following reactions are will produce tertiary alcohol? Just now I told you the concept here. So the concept is ketones will produce tertiary alcohols. Correct na? Ketones. So ketones will produce tertiary alcohol. That is the answer. Correct na? So formaldehyde will produce what? Just now I said formaldehyde will produce what product? Primary. This acetaldehyde or these two, any of these two will produce secondary. This will produce tertiary. Okay, done. Next question. Preparations of phenols. Now carefully let us go to the preparations. Basically phenol preparation, I think you are understanding the concept and we are applying in the questions. Any doubt, please ask me in the comment section. So basically phenol preparations, I can prepare phenol 1 from chlorobenzene. Okay, I'll tell you how what to remember. Chlorobenzene is 1. Okay, then I can prepare phenol from benzene. This is the second one which we are doing. I can prepare phenol from aniline. Okay, I can prepare phenol from aniline, and the last one I can prepare phenol from cumene. Okay, cumene. Alright, now how to remember, what to remember? Actually there's nothing much magical in this, or nothing much. It's an easy concept. There's nothing much to remember, but simple. formation of phenoxide ion is what is the concept here. Okay, so first thing, in chlorobenzene I am using sodium hydroxide at 623 Kelvin at 300 atmospheres. First, the bond here breaks, yes, because it results in the formation of a stable sodium phenoxide ion. That is what is important. Maximum students, they tend to break the bond here and add and make it OH. Wrong. First it has to form a stable phenoxide ion, then in the presence of H plus you are converting into phenol. Yes, so what is the concept? Chlorobenzene, before converting into phenol, it has to form sodium phenoxide, then it will form phenol. Okay, right, this is one. Next, benzene. Yes, nothing, oleum, we are using H2S2O7, fuming sulfuric acid, there the electrophile is SO3H, so it goes and adds, and again before you get OH, try to add NaOH. Now here again the step is not shown, but sodium hydroxide in the presence of acidic medium forms phenol. Got it? Here also careful, when you are converting benzene, try to convert using oleum to benzene sulfonic acid, then you are converting to phenoxide, and then you are converting to your phenol. Okay, then converting to phenol. Is it okay? Next question. And then next question is aniline. Okay, now aniline, this is diazotization reaction from diazonium salts. So BDC you're taking, you're adding NaNO2 in HCl at 0 to 5 degree. First aniline converts to BDC. BDC, when you warm you get water. Next, cumene reaction. As I said, cumene is nothing but cumene is nothing but your CH3 groups. Whatever CH3 groups are there, na? This is your cumene. The reaction is simple. It is understood cumene. Cumene in the presence of peroxide. Okay, so it forms cumene peroxide, there 2 OH, and then further in the presence of H plus and water you get OH. So ma'am, this reactions, basically how should I remember for the exam? That is what. So understand that before we solve the question, understand carefully in every reaction. As I said, see here aniline, what is happening? Aniline is getting converted to BDC. BDC is getting converted to phenol. Correct now. Now cumene is converted to cumene peroxide and it is converted to phenol. So this steps of one after the other step, that you should remember, because you are going to use this in your conversions. Okay, so chlorobenzene to sodium phenoxide to your phenol. So the reagents are very important in this case. Careful, I'll be using these reagents. Carefully you see in the question how it is asked. Okay, let us go to the first question. Now they said phenol is obtained from cumene. Okay, I know that. Phenol is obtained from cumene. How? Which position? How did we get? Yes, we have done, or we have taken the step by step. First we used oxygen, means we did which procedure? Oxidation. And after that we took one acidic medium, correct na? This acidic medium, no, basically under suitable conditions, what is this? This is all, no, oxidation is simple, but here further the same thing, using on heating with sulfuric acid, we are doing auto-oxidation process. So here atmospheric oxygen, oxidation, after that which gives cumene peroxide. Now which on auto-oxidation? So I can write this as auto-oxidation is giving me phenol. So whenever this procedure is there, reagents and the process is very important. Now come back. Phenol is produced from cumene by which process? It's nothing but first atmospheric oxidation followed by auto-oxidation. So atmospheric oxidation is of O2 and auto-oxidation with sulfuric acid in the presence of H plus ion. Okay, remember this. Next question. The products X and Z in the following reaction sequence is what? What are the products X and Z in this reaction? Okay, so what is given to me? Benzene ring is given, alkene is given. Okay, AlCl3 is given to me. Okay, AlCl3 is given to me and you're heating it. Then okay, so basically you're giving a double bond. Okay, now then after that they have converted, or they have made this, they have converted into X, Y, and they have taken, okay, all right. Then acetone. Okay, I think there's a small confusion in this reaction. One oxygen, then H plus in this one. Okay, there are two different reactions, students. Actually, let us first take this. Let me understand. Let us take this reaction. It produces phenol and then Z. Okay, now understand. Now, question here is, this is one set of reaction. Okay, this is one set of reaction. One set. Then this is the second set of reaction in the process. Okay, I'll club both and I'll show you what it is. Chalo, I'll explain it. First, what did they say? They have said they have taken benzene ring with alkene and here AlCl3. Correct, na? And what happened? So they have taken benzene. They have added this alkene, propene, in the presence of AlCl3 and ether, and you're heating it. Correct, na? So what happens? The bond breaks and this alkene goes and adds to this benzene ring. Okay, now how does it look? It looks like your CH, your CH3, your CH3. Okay, done. Now you see, observe what is this? This is cumene. Correct, na? Cumene. Now what is the other name for this? Or it is also called isopropyl benzene. Isopropyl benzene. This is okay. Now this is X. This X, no? Here this X. This is the X. This is the X. Now I understood. Now to this X, what did they do? They have done oxidation at 130 degrees centigrade. So what will happen? It will form cumene peroxide. Correct, na? It's going to completely form cumene peroxide. This is your CH. This is your COOH bond, and your ring is here. Okay, done. Now what did they do next? They did H plus and water. Okay, now this cumene peroxide is Y molecule. Correct. Now they have taken this H plus auto oxidation process by heating it. Cumene peroxide, the bond breaks and you will get here one compound, one product is your phenol molecule and one more is your acetone molecule. One is phenol and one is acetone molecule. So this is how. So go back to the reaction. Now what is this? This is Z, XYZ. Over. Hope you understood this. Yes, this is the reaction, students. So carefully understand. Now what did they ask? What is X and Z? What is X, students, here? X is cumene, Z is acetone. What is X? X is cumene, X is cumene. Okay, X is cumene and Z is this. Now where is the option here? We got no, X is cumene. Where is this cumene? Cumene peroxide rather. Okay, cumene and cumene peroxide. Did they give me cumene peroxide? They didn't give me cumene, but they gave me cumene peroxide. Okay, then acetone. So option B, closest one. Cumene and cumene peroxide. See here, cumene peroxide, and they asked me X and Z. Okay, that's all, because X and Y option, basically here according to my answer, I got X as cumene, Y as cumene peroxide and Z as acetone. I got X as cumene, I got Y as cumene peroxide and Z I got it as phenol. No, Z I got it as acetone. So closest answer, I am marking that. Okay, so this is what I got. I think it's clear. Chalo. Next question, students. Let's go to the next question. Ethereal solution of an organic compound X when heated with magnesium gave me Y, which on treatment with acetaldehyde followed by acid hydrolysis gave 2-propanol. Identify the compound X and what is Y known as. First of all, what is ethereal solution means? Nothing, it's easy. Ethereal solution means when a substance is dissolved in ether, or a substance is dissolved in a solvent called ether. Okay, what is ethereal solution? When a particular substance is dissolved in a solvent ether, then I call it as ethereal solution, basically diethyl ether. Okay, now they said ethereal solution of an organic compound X when heated with Mg gave Y, which on treatment with acetaldehyde followed by acid hydrolysis. Okay, so basically what is the product formed? 2-propanol. Now start from there, start from the product. 2-propanol. 2-propanol. Let us write 2-propanol. I have written 1-2-propanol. Okay, this is CH3, this is CH2, and this is CH3 propanol. Now go back. Did they give me anything? They gave me X, they gave me acetaldehyde. So I can use that, right? Okay. Now to get propanol, means they said there is acetaldehyde which is there. Acetaldehyde is there. That means to get propanol, I already have 2 carbon atoms. Correct na? To get propanol, I already have 2 carbon atoms. That means one more carbon atom should be there here, where I can use with Mg. Correct na? Understand? Already 2 carbon atoms are here. I need one more, only 1 carbon atom, because that is X, and that is reacting with Mg in ethereal solution, that is dry ether, and I'll be getting CH3MgBr. Correct na? Now what did I do? What did they do? They said this tree is reacting with acetaldehyde. Okay, this MgBr, which is Y, is reacting with acetaldehyde, CH3MgBr. Correct na? And this is in dry ether. Correct no? This one in dry ether. Okay, so what will happen when you do? You will be getting this whole molecule goes and adds here, and you will be getting OMgBr. OMgBr. Correct na? Yes. This molecule CH3, CH2, these 3 carbon atoms are linked here. You get. Now this is minus charge and this is positive charge. Correct na? So now I do acid hydrolysis, H3O plus. Then when you do acid hydrolysis, the same molecule is there, CH3, OH and MgOH, Br is out. That's all. MgOH, Br is out. Easy, easy. Now go back to the question. Hope you understood this, students. Now how did I analyze? You understood? Yes. Now go back. Now see. They said statement which is the following. What is Y known as? Identify the compound X. So you will write compound X is methyl bromide, and how did I know? I knew it from the product. And compound Y is, yes, methyl magnesium methyl bromide, methyl magnesium bromide, and that is nothing but Y, CH3MgBr. Easy, very easy. How did I know? You understood the concept. Chalo. Next question. Careful. Let's start with the physical properties. If you didn't, please pause it and note it. Chalo. Next question, students. Physical properties. Now careful. The preparations and everything we did, careful. Now gradually I'll be doing more questions. Let's go into the physical properties. So basically physical properties questions always are, or they talk based on 2 concepts, physical properties. One is boiling point and one is your solubility. This is what maximum topics move on. So remember, boiling point increases when carbon chain size increases. Do you all accept? Carbon chain size increases. Correct na? This one? No. Next, solubility decreases with when carbon when carbon chain or alkyl or aryl group, when alkyl or aryl groups size increases. Correct na? These 2 concepts remember? Yes. Now we will start. First one, when I talk about boiling point, remember boiling point of alcohols is, and phenols rather, boiling point of alcohols and phenols or more or rather increases. When does it increase? Alcohols and phenols boiling point increases when, as I have written, when carbon atoms increase. Do you accept this? Correct na? According to this? Yes. Now point number 2, remember in alcohols, what is important in boiling point? As branching increases, I'm increasing the branching. It's going on increasing. As branching increases, boiling point decreases. Ma'am, why? Because as the branching increases means the surface area is decreasing. It's going inside and inside and inside. What will happen? Reason, the van der Waals forces which are holding them, the van der Waals forces are decreasing. Correct na? Yes. Because the decrease in van der Waals forces, which it will make the boiling point less. Easy. Now we'll take one example and understand what I said. Let us see. Suppose boiling point trend or boiling point trend. Now I have CH3, C, CH3, OH, CH3. This is molecule A. CH3, CH2, CH2. No, we'll make CH3 and this is one OH here. This is molecule B. Now CH3, CH2, 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 OH. Now you tell me, this is molecule C. Now among all these, which will have lesser boiling point? Just now I said na, as the branching increases, surface area decreases, van der Waals forces decreases, so boiling point decreases. Easy. So सबसे कम, सबसे ज़्यादा. Here no branching, surface area more, van der Waals forces more, boiling point more. Simple question, very simple. So boiling point of alcohols and phenols, careful, they are very high compared to hydrocarbons, ethers, haloalkanes and haloalkanes. Means comparable molecular mass. When you see now, the boiling point is more in alcohols than phenols. So that means indirectly, if I have to talk about this in comparison between this, now this is my hydrocarbon. Okay, this boiling point means this in 1 2 3 4 1 2 3 4 5 6 7. So same 1 2 3 4 5 6 1 2 3 4 5 6 7 1 2 3 4 5 6 7. Now if I compare both of the similar thing, hydrocarbon will have less compared to OH. Reason hydrogen bonding is there in this. Now we will see. Now same thing C, if I say CH3, CH2, OH, this boiling point will be more compared to your ethers, because in alcohol hydrogen bonding is there. Okay, so careful. So among your alcohols, phenols, they'll have more boiling point compared to your haloalkanes, haloarenes and your basically ethers and hydrocarbons, all because of hydrogen bonding. Correct na? Before we go to this question, one more concept which I have to tell you, solubility order. Remember students, I am writing here, solubility always depends upon your hydrogen bonding. For alcohols and phenols, the solubility is high because they form hydrogen bonding. Yes, alcohols and phenols. So here when I say hydrogen bonding means simple concept, I'll write here alcohols, phenols, solubility is more due to hydrogen bonding. Now if somebody is asking me compare between alcohols and like same alcohols, suppose they're asking me to compare between butanol and hexanol, which will have more boiling point? Butanol and hexanol. Butanol will have, because the chain or whatever is there, the alkyl chain, the hydrophilic part and the hydrophobic part, more the alkyl chain. Okay ma'am, we're not understanding, I'll explain that. Now see here, this is there, 1 2 3 4 is there, and one more compound, 1 2 3 4 5. Now you tell me, this is hydrophobic, it fears, it doesn't like water. Here hydrophobic means it has the fear of water. Now this, so here hydrophobic part is only so much, hydrophobic part is big, so This is having more boiling point, more solubility, because with less hydrophobic part it will dissolve in water. Here the hydrophobic part is more, that's why it is less soluble in water. Got it? So depending upon the alkyl group, the solubility depends. Lesser alkyl group means more solubility. Okay. Chalo, next question. Let us see this. Which of the following compounds decrease? Which of the following compounds decrease? Arrange the following compounds in the decreasing order of their boiling point. Okay, simple. Now concept is what? Alcohols. Now see the carbon chain difference. This is propane 3 carbon atom. Here butane 4 carbon atom. Here butane 4 carbon atom. Here 5 carbon atom. So based on the alkyl chain. Careful. Now ma'am, problem here is between 1 and 2. How to solve it? So now simple concept. First of all, you start arranging it and see. Subse in a decreasing order, they say. Decreasing order means the one which will have the less one should be at the last. Okay. So subse kam wala is what? 3. It will be at the last because the carbon chain is small. Okay. Now among all, which will have highest? Which will have highest? Sorry. Which will have highest? Pentane or butane? Let me say. Now you should also check the concept of surface area. Correct na? Surface area. Now in this case, propane to all, if you see, it is like this. 1, 2, 3, 4. The surface area is more. Correct. Now let us see one more. Butane to all. Second one, butane to all. 1, 2, 3, 4. This is second. And next butane one all. 1, 2, 3, 4. And the last pentane one all. 1, 2, 3, 4, 5 all. Now you only tell me the surface area here. The surface area in this case, butane to all or pentane to all. Which one surface area? In all the 3 cases, the surface area is more. In all the 3 cases. First case, second case and third case. So compared to the carbon chain and alkyl group, I am picking up option pentanol, fourth option first based on the alkyl group. Okay. Then fourth pentane 1 all, because the surface area is more. The surface area is more, it will have more boiling point. Correct. Then comes your 2. Then comes your, what is this? Sorry students, this is bothering me. 4, 3, 2, 1. This is one option 1, propanol. 4, 3, 2, 1. I'm sorry. So here surface area is less, boiling point is less. Correct na? Got it? So 4, this is pentane. 3 option butane. 2, because surface area is less. Propane, the carbon atom is less. Correct na? Yes, easy? Easy. 4, 3, 2 and 1. So option C is the correct answer. Easy? Chalo, right. Next question. Arrange the following in order. Arrange in order of boiling points. Arrange in order. Okay. Right. So this actually some window is popping up always. Some virus, I think. I'll get my this one checked. Okay. Arrange in order of boiling points. Okay. Now this is ether. This is also a bigger carbon chain. This is also a bigger carbon chain. But compared to this one, alcohol will have more boiling point because of their hydrogen bonding. So first we will go with the carbon chain and acid. Here 2 oxygen atoms means 2 hydrogen bonds. Then comes alcohol, then comes ether. So in the first case, because of 2 oxygen atoms, the acid will have more boiling point because two hydrogen atoms. Then comes C4H9. This is 1 hydrogen bonding here and here. Now if I have to tell you, here hydrogen bonding, here also. Oh yeah, here 1 and 2. The last one will be ether. Okay. This is over. Next thing. Now here when I compare, which one? This one. See, this so many 3 oxygen atoms. That means this will have more hydrogen bonding. More hydrogen bonding means more boiling point. Next comes your alkyl chain. C3. This is C2. This is C3. So C2 more alkyl chain and oxygen atoms. Then comes this group. See this. You observe this oxygen atoms, the more are there means you'll have more boiling point. That's all. More oxygen atoms, more boiling point. Is it okay? Easy? This is the molecule. Compare, done. Perfect. More oxygen atoms, more hydrogen bonding. That's all. Next question. Boiling point of ethers are much lower than those of alcohols of comparable molecular masses. Right. Ethers is lower, they're saying. See, in ether, this is your ether, correct na? And this is 5. And alcohol of comparable molecular mass. They're asking me of comparable molecular mass. Now, if they're asking comparable molecular mass means 2 plus 2, 4 carbons I have to write. CH3, CH2, 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 OH. Now, how many carbons? 1, 2, 3, 4. Here also 2 to 4. Now, here in this case, there is no hydrogen bonding. Correct na? No hydrogen bonding. It's just an... But in this case, there is an hydrogen bonding. Because of this H bonding, the boiling point of... So, you should write there is no hydrogen bonding in ethers, and hence boiling point is less. Here there is hydrogen bonding, hence boiling point is more. That's all. You see? Yeah. Next question. Why lower alcohols are soluble in water while higher alcohols are not? Lower alcohols are soluble in water, it seems. Okay, lower alcohols and higher alcohols, what is the difference? Yes, let us write lower alcohols. This is my lower alcohol, means a smaller carbon chain. Let us write a bigger alcohol like this. Now, in this case, the carbon chain or the alkyl chain, this is the hydrophobic end. Hydrophobic end means it has fear of water. It will not dissolve. Correct. Now here the hydrophobic chain, hydrophobic end. Here the hydrophobic end is bigger, larger. Correct. This is smaller. This is larger. Now you only tell me if the hydrophobic end is larger, what will happen? Solubility decreases. If the hydrophobic end is smaller, and that too they form hydrogen bonds, also hydrogen bonds, that's why their solubility is more, is higher. That's all. Correct now? Yes, lower alcohols are soluble because of this. So formation of hydrogen bonds and solubility. That's all. Next question. Alcohols of low molecular weight are what? Low molecular weight are soluble in water. Yes, they are. Soluble in water and heating, insoluble in water, insoluble in all solvents. So basically, concept is whenever you are talking about alcohols, first of all, alcohol concept only means hydrogen bonding. Okay. So lower alcohols means, careful, they have hydrogen bonding. Because of hydrogen bonding, what will happen? Now, an important thing is lower alcohols means I am talking about concept called low molecular weight, because atom number of alkyl groups are less, no molecular weight, and then they have hydrogen bonding. Now this hydrogen bonding, an important thing is the hydrogen bonding is polarized, means it forms a moleculic, a type of bond between alcohols and this one. How? See this. This is R, this is O, this is H. Okay, lower alcohols, suppose. It forms hydrogen bonding in this way. This bond. Okay. Then from here, HOH. Okay. From here, OHH, like this, lower alcohols. So what will happen? Lower molecular weight, it forms hydrogen bonding. Because of this hydrogen bonding, the solubility increases. Is it okay? Easy? Yeah. So what option you will write? You will write it is soluble in water. So next question. Which of the following has lowest boiling point? Okay, para-nitrophenol, metanitrophenol, orthonitrophenol and phenol. If this question is given to you, students, I will give you one important option, a clue. Remember that and go. I am giving between phenol, okay, orthonitrophenol, okay, I am not writing the structure, orthonitrophenol, okay, orthonitrophenol, then metanitrophenol. Remember this and go if this question is given to you, boiling point. Paranitrophenol, okay, paranitrophenol, okay. Remember, always phenol has intermolecular hydrogen bonding. Intermolecular, inter means between. This ortho has intra. Intra means within the molecule. Meta and para also have inter. It is between the molecules. Between the molecules. Is it okay? Between the molecules. Now when it is inter, careful. Here hydrogen bonding is strong. Hydrogen bond is higher, stronger. Wherever there is inter, na, the intermolecular, the hydrogen bond is strong. So here in this case it is within the molecule, it's within the, like, it is closed inside the molecule. So this is internal hydrogen bonding. So what will happen, ma'am? Internal hydrogen bonding. Now you only tell me, when the hydrogen bonding is between the molecule, when the hydrogen bonding is between two different molecules, between two molecules, then what will happen to this? Automatically the boiling point will be high. Correct, na? It is between two. You need to break the bond between two. Here it is internal hydrogen bonding. It is inside. So what will happen? The boiling point is lower. Okay, and less soluble in water also. Here again it is between. That's why the boiling point is more. Okay, clear? So what is this concept? The concept here is phenol has inter. The last one, paranitrophenol has inter. Then metanitrophenol has inter. Then orthonitrophenol is intra. Phenol is inter. Correct, na? So which one? Which is the lowest boiling point? So whichever is intra. This one. So the option C is correct. Okay, easy question. Alright, so again students, we'll meet with one more topic. As I said, we are going to study about chemical properties, right? So after, till now, what did we complete? We have completed classification, we have completed nomenclature, we have completed your this one, what do you say, preparations of which one? Of alcohols, of phenols. Ethers we didn't do, we will do at the end. Phenols, then we did questions based on all MCQs, we did 1 mark question, we did 2 mark questions, we did till now. So I'll meet you again now next with chemical properties. Let's start the chemical properties. Alright, now let's start with the next topic, that is nothing but your chemical properties of alcohols and phenols. Till now we have done different topics. So basically now let's understand what to study and what are the different concepts in the chemical properties. So basically maximum questions in the alcohols chapter are going to come from your chemical properties. Please remember students, because this is a concept based topic. Correct, now everything is conceptual, so you need to understand the concept and apply in the questions given. So I'll explain you the topic in detail, then we will do or solve questions or MCQs rather than 1 mark question, then 2 mark question, 3 mark question, your 4 mark question, as well as 5 mark. So gradually we will do all, so concentrate carefully and understand. Now in chemical properties of phenols, first important thing to understand is your alcohol, whatever are there, ROH, this is your alcoholic functional group, correct? So this alcoholic functional group will give us 2 varieties of reactions. What are they? The reactions which are involving the cleavage of RO bond or the carbon oxygen bond is one, and it also involves the it also involves the breakage or the reactions involving oxygen hydrogen bond. Is it okay? So both the reactions between cleavage CO bond is 1, oxygen or reactions between oxygen and hydrogen bond is 1. Correct? Alright. Now first thing, as I said, alcohols are going to behave both as your nucleophiles and they're going to behave as both as electrophiles. So what is the use of this learning? Because based on this only, it's going to show different varieties of reactions. That's the reason, both as a nucleophile and electrophile. How? Suppose if I take an alcoholic functional group in this way, how many electrons are there? 1, 2, 3, 4, 5 and 6. Correct? Now let us assume a particular, any alkyl halide is reacting with this. Let me take one tertiary alkyl halide. Okay, one tertiary where 3 alkyl groups are there to this. Now as I said, I'm not writing the bromine part or the halogen part, I'm just maintaining as tertiary carbocation. So initially what happens is this pair of electrons is shared with the carbocation, tertiary carbocation. So what will happen to this? Then the molecule, the oxygen atom is going to possess a positive charge and the remaining alkyl groups are there. Now this is not stable enough, correct? Because being electronegative, it can't have the positive charge. So further, when it is attacked by, when a proton is removed from this, you will be finally getting an oxygen atom, carbon and 3 groups. You're able to observe here what is happening here. Alcoholic group is donating electrons, means it is acting as a nucleophile, a nucleus rich or electron rich compound, because it is donating it to the carbocation. So this is one way of doing reactions. Now same thing, if somebody is asking how alcohols are behaving as electrophiles, how are they trying to get the positive charge, I'll show you how it is. So here remember, protonated alcohols, that means an alcohol which has pair of electrons here. First, as I'm showing you, first it's donating the pair of electrons to the proton. When it is donating the pair of electrons to proton, what is happening here? Again, oxygen is getting the positive charge. I should show how it is acting as an electrophile, right? Now I'll show you. Now this is the oxygen atom. Now oxygen atom is not stable, so what is going to happen? It's going to take up, or a halide rather, a halide comes and gives its pair of electrons to your alcohol. Is it not taking the electrons now? Because a negative charge or the nucleus rich alkyl halide is coming to a particular compound, means it's an electrophile, isn't it? It is acting as an electrophile because there is deficiency of electrons here. So finally it takes that particular alkyl halide and it's going to convert into bromide. Easy. Here in this case, because it is accepting, it is acting as an electrophile. Here it is donating, it is acting as a nucleophile. Easy. So alcohols are reacting with both electrophiles as well as nucleophiles. Easy. Very easy. Now next concept, what you should do. Careful. Hope you have noted this. Take it and note it in your book. Now I am going to tell or compare the acidity of reactions between comparison between the acidic nature of, this is very important concept, acidic character or acidic nature. I am comparing acidic nature between your alcohols and between your phenols. We are going to understand which one is more acidic in nature. Okay, acidic in nature, that is what I need to understand. First of all, acidity means what? The one which reacts with the metal and releases hydrogen gas. Correct na? The reaction where they can donate a pair of electrons. Okay, simple way if I have to say, acidic nature means where the particular compound can donate a pair of electron. Okay, they can donate, not electron, proton rather, H plus ion. When they are donating H plus ions, that means they are acidic in nature. Correct na? How they are donating? Suppose your OH is here, your alcohol is here. Okay, now what happens? Oxygen is more electronegative. It will drag the electron density. It becomes negative charge and this becomes positive charge. Now a metal atom is reacting with this. So what is there in this metal? There is Na plus plus 1 electron. Correct na? Yes. So what is going to happen? Your positive charge and your negative charge is there, right? So your positive goes and attacks your oxygen atom. What do you get? You'll be getting RO minus Na plus, and your hydrogen gas, how much is there? It is only half hydrogen gas is out. So what is happening here? Your alcohol or the alkoxide, it is here, in this case it is donating a proton which comes out in the form of hydrogen gas. Correct? That means, is it not acidic in nature? Yes, alcohols are acidic in nature because they donate protons. Same thing if I take phenols in this case, again phenols have OH. This is electronegative, it drags the electron density. Then again this becomes partially negative, this becomes partially positive. Now your sodium metal is reacting with phenol. What happens? Your sodium metal, rather, when I say Na plus 1 electron, so this goes and attacks your oxygen atom. What do I get? I'll be getting sodium phenoxide, RONA, and automatically there is release of hydrogen gas. Now in both the cases, because there is release of proton, I say alcohols and phenols are acidic in nature. Is it easy? Very easy. Now what is more important? Comparison is important. Further, if I have to take, here metal we have taken. Now what happens? Suppose in phenol, now I am going to take the same phenol, and I said it is acidic in nature, because it is donating the proton. Now same thing if I say, if this is acidic, if it is reacting with sodium hydroxide. Now sodium hydroxide has two different ions, Na plus ion and OH minus ions. Correct? So what will happen? Na plus goes and attacks your O minus, and you will be getting sodium phenoxide, and you will get water. What is this now? See here. This is nothing but neutralization reaction. This is acting as an acid. This is acting, or this is a base. This is a salt, and this is water. Salt and this is water. So acid plus base gives me salt plus water, which is a neutralization reaction. Correct? So neutralization reaction, this explains phenols and acids, phenols and alcohols are acidic in nature. Okay. Now if they ask you the polarity, what concept should you remember? Remember, basically in alcohols, when I take an alcohol in this way, CH2OH, this is one alcohol. Correct? Suppose if I take further more alcohols, means I am taking a secondary alcohol. Now I am taking one more tertiary alcohol. Now tell me which is more and more acidic in this case. Careful. Yes, careful. See here. Here oxygen is only pulling. So less electron releasing groups, means oxygen is more stronger compared to your CH2. So this is more acidic. In this case, this and this are electron withdrawing groups. This is also electron withdrawing groups. So now what happened? This is donating electrons, this is donating electrons. The electron cloud is becoming more and more in oxygen. That's why this is less acidic compared to the first one, primary. In the last case, there are a lot of alkyl groups. That means the electron cloud is more. This is the least acidic. Now what to understand? More of electron releasing groups are there in the particular ring. Electron releasing group means CH3 group, C2H5 group, or alkyl groups. More alkyl groups means the density in oxygen increases, and what will happen means that is the breakage or the bond to break, because already it is excess. So the bond will not break. If the bond doesn't break between oxygen and hydrogen, where will the proton release? If the proton is not released, means it is less acidic. So remember, more electron withdrawing group means acidic strength decreases. More electron withdrawing group means acidic strength decreases. This is clear? Careful. Electron releasing, electron releasing groups. More electron releasing groups means acidic strength decreases. So electron releasing, not withdrawing, electron releasing groups. So electron releasing groups increases, acidic nature decreases. This is okay. Remember this concept. Okay. Now next question. If they ask you compared to phenols, okay, this somebody is asking you a question. Phenols are more acidic than alcohols. Explain, they ask you. Phenols are more acidic than alcohols. Why they are asking you? How will you answer? First of all, we'll compare. Now this is my alcohol. Now in this case, this is my phenol molecule. Now you tell me, what is a hybridization here? This is all single bond, correct? Na? But oxygen, hydrogen, yeah, that is fine. But there is no ring or nothing, correct? Na? So here when I see, this is sp2 hybridized carbon because double bonds are there. So what will happen? sp2 hybridized carbon, here the chances, because it drags the electron density, the chances of breaking this bond, easy na, because electron density, it's trying to drag. So what will happen? The bond, whatever is here, it is more and more polar. And here compared to this, because this is electron releasing group, here the bond is less polar, correct? If it is more polar, then only it will cleave the bond, then only it will give me the proton, correct? Na? Yes. So when I break this, what happens? ROH is breaking up into alkoxide ion and your proton. In this case, phenol is breaking into your phenoxide ion as well as your proton, correct? Na? Yes, this is your proton. Now you tell me, in both the cases, where is the possibility, where is the negative charge delocalized, correct? Here in this case, in the second case, the negative charge whatever is there is delocalized over the conjugate ion. Here the conjugate ion whatever is there delocalized. Now what happens? This phenoxide ion, it tries to undergo resonance because of the pi electrons, na? It undergoes resonance. It undergoes the shift of pi electrons is there. So in this case there is no resonance, in this case there is resonance, correct? So now what will happen when it is resonance? Because of the resonance, the particular phenoxide ion is more stable, correct? Yes, it's more stable. Now simple concept, both the things. First, bond is more polar, this is one factor to become acidic. Second, the phenoxide ion formed is more stable. In both the cases, or these two conditions will explain me that phenols are more acidic. So what factors you will say? You will write both. Bond is polar, first case. Second, phenoxide ion C6H5CO C6H5 O minus phenoxide ion is resonance stabilized. Because of these two factors, phenol is more acidic, or the stabilized phenoxide ion. Easy? Yes. So next question, let us carefully understand before we go. So till now what did we learn? We have learned the concept of electron. If electron releasing groups are increasing, acidic strength decreases. Compared to alcohols, phenols are more acidic than alcohols, correct? Na? These two concepts is what we have studied. So before we go to this this particular question, let me explain you few trends, what are they, and then understand. Okay. Now they will ask you a question based on your Ka values. Okay. You should be very, very careful with the concept of Ka. What is that Ka in relation with your acidic strength? We'll explain. Now what did we say? Your phenoxide ion is resonance stabilized, or phenoxide ion is more stable because of resonating structures. So what happens? The phenoxide ion, the resonance or the negative charge, which if I have to show you, the negative charge is mostly concentrated at the ortho position and the para position, correct? Na? Yes. So negative charge is trying to stabilize the phenoxide ion by two factors. One is minus I effect and one is minus M effect, correct? Because of this minus I and minus M effect at the ortho position, these two effects will try to increase acidity. It will increase acidity, understood? So the ability to drag the electron density. So careful, minus I pulling the electron density. So because of this, phenol is more and more acidic in nature, correct? Now careful is when you are comparing between three of them. In phenol, what are there? Orthophenol is there, para and meta. Three positions are occupied. Or orthonitrophenol. Suppose if I take this ortho OH This is orthonitro. Second is your para-nitrophenol. Third is your meta-nitrophenol. Okay, meta-nitrophenol. Now you tell me ortho, para and meta. Among all these three, which one is more and more acidic? Why? What is the problem and what it is? They may ask you a question about this. Yes, you're going to justify why it is and what. So careful, according to the order para, ortho and meta. This is the order, POM, remember, acidic order. Because this electron withdrawing group, they try to drag the electron density and make the bond weaker here so that this proton is out. Here it's very close, isn't it, to drag? So, okay, here para also, when it see, it is closely packed in the crystal lattice. That's the reason when it drags the electron density, this proton moves out. Is it okay? Yes. So careful. So what you should remember is the acidity order. Suppose if somebody gives you three questions, what are they? Compare the acidic order between your phenol and compare the acidic order between an electron withdrawing group which is at ortho position. Now tell me which one will have. As I said, this is electron withdrawing group. Now understand, if electron withdrawing group increases, what will happen to the acidity? Yes, the acidity increases. Now earlier case, what did I say? If electron releasing group increases, the acidic nature decreases. Now electron withdrawing group increases means acidic nature increases. It can easily release. Now among both of them, which is more acidic? This one. Correct, no? Because it is electron withdrawing. Now I am asking you to compare between a phenoxide ion and a ring which is NO2 and O minus. Among both of them, which is more acidic? Again this one. This is stable, correct na? This is stable phenoxide ion. Suppose if somebody is asking me to compare between OH CH3 and your OH NO2, which one is more acidic? This is electron releasing group, ERG. This is electron withdrawing group. As I said, more of electron withdrawing group, the acidity will be more. That means this is less acidic than easy. So carefully understand electron releasing group and electron withdrawing group. There is no confusion. So I am summarizing before I go to this question. Careful students. Electron withdrawing group more means, what is more? Acidic nature is more. Electron releasing groups are more means acidic nature is less. Careful, because it will not allow the proton to break, means the bond doesn't break there much. Okay, chalo, with that question let us understand. Arrange the following in the decreasing order of their acidic strength. So there is the given. So first of all, as soon as such question is given to you, write down with your pencil, this is electron withdrawing group. Correct? Right. Next, this one. This is electron releasing group, donating or releasing group. Correct? Now what will happen? As I said, more of electron withdrawing groups are there. I am writing here, more of electron withdrawing group in case of para-nitrophenol. What are there? In the case C, this is C. In case of para-nitrophenol, what effect is observed? There are two effects which are observed. One is minus I effect, that is dragging the electron density, and minus M effect, that is pulling through the concept of the resonance. What will happen? This will stabilize the negative charge on the phenoxide. So two things will happen because of this. Negative charge on phenoxide is stabilized. And automatically what will happen? The acidity increases. This is okay in this case? In this case, yes. Now after that, phenol. Does phenol have any substituents? This is option B. Yes, phenol has no substituents. Additional substituents it doesn't have. Additional substituents, no additional substituents. So what will happen? The acidity will be moderate. Acidity is moderate. Now in the first case, that is para-methoxyphenol, correct na? Para-methoxyphenol, more electron releasing groups. Para-methoxyphenol, more electron releasing groups. So what will happen? What effect is there here? The effect is plus M effect, correct? Now what will happen? Whatever negative charge is there on the phenoxide, negative charge destabilizes. Then what will happen? Acidity decreases. This is okay? Yes. So go back. Now answer. Careful. They said decreasing order. The one which is least should be at the end. So A is the last. The one which is more is the first. The one is between this option C, B and A. Easy? Very easy option. Chalo, next question. Careful, I'm explaining very detailedly. Go understand. And so now the correct order of acidic strength of the phenols. Okay, now write down. This one is electron withdrawing. This is also electron withdrawing. This is electron releasing group. Now what did I say? Para always, in all the cases. Para, you should check. How do I know para? When it is opposite to each other, functional group and nitro, this is para. This is para. C is para. Correct? Para has strong effect of minus ion. Let us go step by step. First, A option. What is that? What did they give me? A, they give me phenol. Phenol, no extra or no additional substituents. So no additional substituents. So what will happen? Acidity is moderate. Acidic character is moderate. It is moderate. Leave it. Then second part, B part. What did they give me? B part. They have given me B. The functional group is present here. Now what is this? It is adjacent to this. That means this is ortho. Correct na? Adjacent to this. Now in this case it is para. This is ortho substituent. This is para substituent. This is also para. Now in ortho, in this case, what will happen? There is one problem here. OH is there. So in B option, careful, there is intramolecular hydrogen bonding. Intramolecular H bonding. This is one concept. Because of this intramolecular H bonding, acidity slightly decreases. Acidity reduces slightly. Compared to para. When you compare this with para, acidity is little bit less. Let us go with the C option. What is C? Now it is in the para position. Correct na? Your C para nitrophenol, careful, NO2 group is electron withdrawing. When electron withdrawing is there, what effects are there? Minus I effect and minus M effect, both are acting. So what will happen? Because of this, it will stabilize the phenoxide. Careful. So acidity will be maximum. Acidity is maximum in this case. Now last but not the least, we have last D option. In D option you have your CH3 group, which is electron releasing. When electron releasing is there, what effect is there? Plus I. Because of this, what will happen? Acidity is less. Acidity will become less. Means it will donate electrons. Electron cloud is more and OH is not broken silly. Go back and answer. So what is the correct one? If I have to tell you the answer, first one or option, correct option, students, go back. So first subset, they said the correct order of acidic strength. So subset zyada among everything, C will be maximum. Did they give me C in this option? C, no. Okay. Did they give me? Okay. There's little bit any kind of okay. C first will be C, correct. Then more will be then B. Then after that A, correct. And then D. Ma'am, they didn't give me any option only. They've given in the reverse order. Let us make it in the reverse order. D is less, then A is less than B is less than C. That's all. They've given this option. So C option is a correct. So among everybody, C has maximum. Among everything, D has minimum. Okay, done. Next, I am explaining in detail. Carefully note the answers. Phenol is more acidic than alcohol. Give reason. Simple answer, only one word answer. You will write due to, only one line. This is 1 mark question. Due to resonance stabilized phenoxide ion. Because of this resonance stabilized phenoxide ion, it will just increase the acidity, because it will stabilize that and remaining is released out. You see? Yeah. Why is phenol acidic in nature? Same answer. Same, na? It is like more acidic, less acidic, same answer. Due to stability of phenoxide ion. You write the same words in exam. By resonance. Is it easy? Very easy. Correct na? Okay. Next question. Out of picric acid and phenol, which is more acidic? Okay. Let us write. What is this? This is easy. Here, this is your phenol. And this is your picric acid. Picric acid has 3 NO2 groups. 3 NO2 groups. This is your picric acid. Okay. Done. Now, in this case, I don't have placed only this one page. Okay, one. In this NO2 group, here electron withdrawing groups are more. Correct. In this, what will happen? There are 2 effects which are acting. What is that? First, minus I effect is acting, where the NO2 will try to withdraw electron density from the ring. It will pull, it will pull, it will pull, and the bond between these two will break. Correct na? So it will release the H plus and it will become acidic. Next thing is minus M effect. So the electron density through the resonance, it will try to pull the electron density through the resonance, and again it weakens the bond and it releases. So compare to both of them, what is more acidic? Out of picric acid, which is more? Phenol is less acidic than picric acid. Correct na? Reason are minus I effect and reason are minus M effect. So you write more electron withdrawing group increases, minus I and minus M effect increases, and acidity, or it will stabilize phenoxide ion, and what will happen? Acidity increases. It releases the proton and acidity increases. Easy. Next question. Which of the following compound is most acidic? Now seeing this you can understand na, it is easy. Very easy. Now see, in this case, in all the cases, I should check for electron withdrawing group. Where is this? This is electron withdrawing group. This is electron releasing group. Okay, correct na? So phenol, there is no additional substituent. Correct, right? So here this is all electron releasing group. Now tell me, among all, which is more acidic in nature? Simple. NO2 stronger, सबसे ज़्यादा. Correct. So electron releasing groups are more, acidity is more. That's all. Easy. So what should you write? Simple reason. If they just ask you what, so you will write C is an answer, C is an option. C is more because NO2 group is electron withdrawing. Because of this, it will stabilize. So basically what happens is, I'll show you why. Okay, it is more acidic. I'll show you. I'll show you the structure. See this case, I'm opting NO2 na. This is your OH group, right? So this is your NO2. Now what happens? It is going to stabilize because the proton is broken here, right? Because it is dragging the electron density. This NO2, 1, 2, 3, 4, 5, 6, 7, 8, and this NO2 and your H plus. Now see this. This whatever is there, this NO2 is going to stabilize the negative charge. This will stabilize the negative charge on oxygen. So what will happen when it stabilizes the negative charge? The equilibrium, whatever is there, it is going to shift in the forward direction. So when it is shifting in the forward direction, what will happen? I can easily remove this proton. Hence it is acidic. Shall I write that? I'll write this. NO2 is electron withdrawing. So what will happen? It will stabilize. Hence it stabilizes. Hence it stabilizes negative charge on oxygen atom. Write the same thing in the exam. Then what will happen? Hence equilibrium shifts towards right, and H plus is easily removed. H plus is removed means it is most acidic. H plus is removed means it's most release of proton is acidity, na? Most acidic. That's all. So option C. Right. Correct. Easy. Next question. Given are cyclohexanol, acetic acid, 2,4,6-trinitrophenol, phenol. These are the decreasing acidic orders. So in these, the order of decreasing. Okay. So they've given 4, na? 2,4,6-trinitrophenol. They have given cyclohexanol, everything. Okay. First of all, if I take the compounds one after the other, we will see what is given. First is what? 2,4,6-trinitro acetic acid for cyclohexanol. Okay, so cyclohexanol. Okay, first one. In cyclohexanol, do you have any significant, stabilization concept of the conjugate base? No, because there is no resonance, na? Correct, na? So when there is no resonance, what will happen? Stabilization of the conjugate base. No stabilization means basically they don't have significant stabilization of conjugate base. Am I right? Of conjugate base. Okay, conjugate base. This is okay. That is ruled out. Next, what did they give me? 2,4,6 acetic acid. Then 2,4,6. Then acetic acid, CH3 COOH. Now in acetic acid, moderately acidic because of the COH group. Moderate acidity. Moderately acidic because of COH group. Acidic. Third one, 2,4,6-trinitropycric acid. So this is your picric acid, 2,4,6-trinitrophenol. So how many electron withdrawing groups are there? Oh my god, 3 electron withdrawing groups. So 2 factors are acting, minus I and minus M. So automatically it will stabilize the conjugate base. Stabilizes conjugate base. So acidity is more. Acidic nature is more. Correct na? D part, what did they give me? Phenol. Phenol, there is no further substituents at all in this. Correct na? No substituents. It is less acidic compared to your less acidic than acetic acid, but more than alcohols. Correct na? Phenols are less acidic than acetic acid, but more than phenols. Is it okay? Okay, done. Clear? I have explained everything. Now go back. Now what is the correct order among everything? Third, 3 comes first. Okay, then comes 2, then comes phenol, then comes cyclohexanol. Correct na? No, phenol and then cyclohexanol. So first comes what? Option A, I think na? Yes. Third, yes. Then 2, correct. Then 4 and then 1. So reasons are here. Understand and you can come back. Now chemical properties of alcohols and alcohols in flowchart as well as phenols also in the flowchart. I am giving this, both of them. Let's understand. So basically alcohols, acidic nature, I think you're clear. This is your flowchart, students. These are all the reactions of alcohols. So basically different has different names that you should remember. Simply don't by heart this flowchart. This flowchart has lot of understanding of which one. This reagent is for what? Lucas reagent. This reagent, Lucas reagent test, and this one is for your substitution reactions. This is for your oxidation reaction. This is for your reduction reactions. Carefully understand everything. Now all these reactions, if you by heart know, you have to apply all these reactions in questions. Apply in questions. So I will be explaining one after the other. Careful. So come back. Let us start with the first one, Lucas reagent test. See this. There is one question. First of all, Lucas reagent is anhydrous ZnCl2. What is the speciality of this? This is used to identify or differentiate or distinguish primary, secondary and tertiary alcohol. So Lucas test is used to differentiate or distinguish 1 degree, 2 degree and 3 degree alcohols. Is this okay? Yes. Now here, as I said, primary alcohols, when you add Lucas reagent, water comes out and your alkyl halide is formed. So this cloudiness or the precipitate, it appears on heating only. That means instantly you will not get result. Now come to secondary. Secondary, same. Water, OH minus is eliminated, Cl is added. Here you will get cloudiness after 5 minutes. Better than primary. And then tertiary alcohols. OH is removed, Cl is replaced and cloudiness appears immediately. That means in Lucas reagent, what is the first alcohol which responds? It is tertiary, then secondary, then primary. Read this question. Which is the correct order of reactivity in the following reactions? Tertiary, secondary, primary. Easy? Very easy. Now, so when you remember this table, you have to remember how important it is to understand this concept. If you understand the concept, it is easy. Correct na? Yes. So the first one or the reaction, whatever you are understanding, if somebody is asking you what is this which is undergoing, which HX is removed, or this HCl or HX is removed, what type of reaction is that? It is nothing but, first one is nothing but your SN2 reaction, nucleophilic substitution reaction. Ma'am, how I'm going to show you that. Careful. First thing, whenever you are taking first reactions involving the cleavage of RO, means I'm breaking CO bond here. First thing, what reaction I'm trying to react with? Just now with Lucas we did na, with HX. Here your X can be HCl.
One moment.
X can be HBr. X can be HI. Okay? Yes? Careful.
Still on it.
Sorry. Once again, students. Okay. Alright. So HCl, HBr and HI. So in these cases, when we are doing the reaction or we are performing the reaction, how is the mechanism and what is the mechanism is important for you. The reason they will ask you what type of reaction is that. See this. I am taking alcohol. 1, 2, 3, 4 bonds are there, right? 5, 6, 7, 8. Now I am adding any of them, HI. This is positive, this is negative. Now the negative charge is taken up by the proton and I will be getting, so this is positive charge, this is negative charge. Now iodine goes and attacks. What is happening now? It is basically a transition state where the nucleophile is going and attacking. Yes, which mechanism is this? This is SN2, correct na? Correct. So you get Ri plus water. So first thing, remember the first reaction is always SN2 reaction. Okay, right. Next we are going to next reactions. Then what we are going to reactions like, PX3, PX5, SOCl2. What are those reactions? It's basically nothing. It's simple substitution, nucleophilic substitution reactions only. So there you are trying to take your alcohol. You are either introducing PCl3 or you are introducing PCl5 or you are introducing SOCl2. The bond breaks and you will be getting alkyl halide. Easy, very easy. Next reaction what we have here is, careful, you are trying to use H plus ions and you are getting an alkene. This reaction is nothing but dehydration reaction. Removal of water molecule. So this dehydration reaction, I am going to explain you the mechanisms further. Just we are learning reactions. I will explain the mechanisms further and then we will go and do all the 5 mechanisms or the 6 mechanisms together. So I will be doing this mechanism later. I will be showing this. Okay, alright. Yes. Next, after that, gradually we are going into one more concept. What is this? This reagent, whatever is there, is nothing but your oxidizing agent. This KMnO4 potassium dichromate is an oxidation process. Careful, let us understand oxidation process carefully. So hope you have understood that. Oxidation I am explaining careful. Now, your alcohol, whatever is there, remember, primary alcohols are on oxidation, they get converted to aldehyde. Aldehydes on oxidation gives us acids. So to convert your primary alcohols to aldehydes, you are going to use weak oxidizing agent, and that can be PCC, CrO3. To convert primary alcohols to acids directly, you're going to use strong oxidizing agents. That's nothing but KMnO4 and H+. Remember this. Got it? So this is the concept. Yeah. Now let us do with the first one, PCC or your CrO3. First reaction. I am going to take alcohol. I am going to use CrO3 or I am going to use PCC, pyridinium chlorochromate. What will happen? I said this is oxidation. What is oxidation? The removal of hydrogen or addition of oxygen. So this hydrogen is removed and you will be getting acetaldehyde. This is oxidation process, correct? Yes. This is which alcohol? This is primary alcohol. Correct? Now, if I use secondary alcohol, what will happen? Second, I am now using my secondary alcohol. I am using CrO3. Now, what is going to happen? This hydrogen, because this is also oxidizing agent, removes hydrogen. 2 hydrogens are removed. Okay, what do I get? I am getting a ketone. So secondary alcohols are giving me on oxidation, gives me ketone. Now tertiary alcohols. I am taking tertiary alcohols. I am using oxidizing agents like CrO3. But remember here CrO3, even if you add, there is no reaction. No reaction. Why? Because there is no CH bond. There is no CH bond. It can't break the CH bond here. Got it? So what is the conclusion of the story? The conclusion of this reaction, what is written here? Na? This one. This part is there. No, this part is there. Na? This part is very, very important for you all. So carefully understand. In oxidation, the summary of the reaction is primary alcohols on oxidation with which one? You are going to use CrO3 or PCC. It will become aldehydes. secondary alcohols on oxidation will give me ketones. Tertiary alcohols, no reaction. If you want to convert primary alcohols to acids directly, you are going to use strong oxidizing agents like KMnO4 or in the presence of acidic medium or potassium dichromate also. This is the concept, very important. Now we are going to learn one more concept, that is nothing but this. This is nothing but, careful students, yeah, we are using oxidation is done. Now before we go to the chemical properties of phenols, the last type of reaction is whenever you see copper at 300 degrees centigrade. There are three varieties of reactions. Reaction 1, reaction 2, reaction 3. With primary alcohol, you will be getting, yes, this is an oxidation reaction. You will be getting removal of hydrogen. You will be getting aldehyde. Second, with your secondary alcohol, you are going to remove hydrogen from here and here, and you will be getting ketones. But when you take tertiary alcohols, these two are oxidation reactions. But when you take tertiary alcohols, the reaction is called dehydration. Careful, the reaction is called dehydration. You are removing water. So water is removed and you will be getting alkene. You will be getting alkene. Is it clear now? Clear? So careful, this reactions with copper, two are oxidation and one is dehydration. Okay, go back and see. Tell me in this reaction. Yes, primary alcohol one is, yes, this is oxidation. This is oxidation. Alkene is dehydration. Is it okay? Easy. So concept is very important. Careful. This one, and this is one esterification reaction which we'll do. So when I do the mechanisms, I'll do your esterification mechanism also. Is it okay? Done. Now next comes your chemical properties of aldehydes, alcohols are over. Now chemical reactions of phenols. So basically these are all the electrophilic aromatic substitution reactions, EAS, electrophilic aromatic substitution reactions. Is it okay? Now phenols, what happens? Phenol and phenoxydione, basically they allow the electrophile, whatever is coming. In this case NO2 is electrophile, in this case bromine is electrophile. Like that, it allows the incoming electron to go and attack at the ortho and para position. Why? Because what happens here in ortho and para position, it becomes electron rich states because of the resonance. Because of this resonance, they go and directly attack at ortho and para. If somebody is asking you why at ortho and para, you say because of the resonance, the particular sites at ortho and para, they become electron rich. Okay, is it okay? Now in this case, first thing what we should understand in detail, all these reactions are there na? So what you should understand. So point number 1 to remember. So first, like if I see all the reactions, we'll explain all this. Now case 1, I'm talking about this reaction. What is this reaction? This is halogenation reaction. Halogenation. So in halogenation reaction, you need to understand or remember 3 things. Your bromine, your phenol, your halogenation reaction. What to remember in this halogenation? If you provide bromine, solvent is important. In carbon disulfide or chloroform, you will be getting 2 products. One is your ortho bromo and one is para. Is it okay? Ortho bromo or para. Among this, para is major. Is it okay? Now Same thing, if you are trying to give bromine water, then you will be getting picric acid. All three, bromo, picric acid. Let me see whether it is recording or not. One second, students. It is recording. Yes. Okay. This is bromine. This is about this reaction. This is clear. This one clear. These two are over now. Clear. Now let us understand your nitration. Nitration, second one. I am taking nitration. In nitration, what should you remember? Basically, in nitro group, suppose you are trying to take your OH and you are taking time to CH3. It's okay. You are adding concentrated HNO3 is 1. You are adding, means basically dinitration. You are trying to do dinitration process. Then what is going to happen is, in concentrated HNO3 you will get both the products. Ortho product. Now this NO, this OH is there, its CH3 is there. One is para product, one is ortho product. The CH3 is there here and your NO2. So which is major? This is major. And in dinitration you will be getting all three nitrogens occupied there. NO2, NO2. All three nitrogens are occupied. Easy? Easy? Very easy. Now careful, nitration is also clear. No doubt in nitration. Okay, nitration also we did. Nitration also is done. Okay, dilute HNO3, concentrated HNO3. Yes, this is what we did. Now we will go into next with your question. Rather, they will ask you one, why is orthonitrophenol more steam volatile than paranitrophenol? This question I think I did in one of the questions. So basically again we will do this question. Why orthonitrophenol is more steam volatile than paranitrophenol. Is it okay if somebody is asking you? Nothing. Easy. See this. Answer is, draw both the structures. Phenol structure. This is orthonitrophenol. Correct? Ortho. Then draw the paranitrophenol structure. At the para position, and okay. Now here the hydrogen bonding is formed. In orthonitrophenol, the hydrogen bond is formed. Here this is within the molecule, intramolecular hydrogen bonding, H bonding. This is between intermolecular hydrogen bonding, H bonding. So now which is more stronger? Tell me. Here intramolecular hydrogen bonding is less volatile. So basically orthonitrophenol, this can be easily broken because it is within the molecule. Now here you need to break between this bond. Correct? So orthonitrophenol is within the molecule. I can easily break it and make it or allow it to undergo steam. It will become steam. Here it is within the molecule, intermolecular, which causes association. So when association of molecules increases, what will happen? It is difficult for me to break the bond. Correct? That's why this is more steam volatile and this is less steam volatile. Is it okay? Easy? Next question. Next reaction, Kolbe's reaction and Reimer-Tiemann reaction is also part of it. So Kolbe's reaction, where you are getting our formation. Careful students, what is that? In Kolbe's, what you should remember? I will explain and then we will understand. In Kolbe's reaction or Kolbe's synthesis rather, okay, there is formation of your salicylic acid. Now in presence of what? We are trying to form, or rather trying to first form the stable carbocation or sodium phenoxide ion. So sodium phenoxide ion, for that we are using sodium hydroxide. Then to form salicylic acid we are using carbon dioxide. In the presence of carbon dioxide you are getting salicylic acid. Correct na? Yeah, that's easy. There's no big mechanism or nothing. But in case of Reimer-Tiemann reaction, careful, this is very important reaction. I think this is easy. Now we will understand this Reimer-Tiemann reaction. First of all, whenever Reimer-Tiemann reaction is happening, okay, I will explain Reimer-Tiemann reaction. In Reimer-Tiemann reaction, when you take this, first of all you are going to take this phenol and you are going to introduce your chloroform and sodium hydroxide. Okay, so when you are introducing this, first important thing what happens is, see this, there is an intermediate which is formed. Carefully understand. You are taking your ring, your O minus, Na plus goes and attacks. Here there is a cleavage. Then your, to this carbon, your chlorine, how many are there? 2, 3 are there, in that 2 and H. And further what happens, you are going to introduce sodium hydroxide. Then you are going to break that bond, this bond here, and replace with this OH. So see, OH, OH and your H. So further there is cleavage of the bond, CHO, OH and your CH. This is your salicylaldehyde, salicylaldehyde, CALDEHYDE, salicylaldehyde. Now what is this? Understand. Whenever you are treating phenol with chloroform and sodium hydroxide, there is a CHO group which is introduced at which position? At the ortho position. So when it is introduced at the ortho position of benzene ring, this reaction, whenever there is a CHO group introduced, such reaction is called RT reaction. RT reaction is a Reimer-Tiemann reaction. So introduction of CHO group at ortho position is called RT reaction. Why? Here when you observe, the formation is happening at the ortho only. Step by step it is happening at ortho. So such reaction, careful. So Reimer-Tiemann reaction is conversion of phenol into salicylaldehyde. Conversion of phenol into salicylaldehyde. Easy? Careful. So I am writing here Reimer-Tiemann reaction. Careful students. Okay. Next question. Before we go to this question, understand there's one more question. In the flow chart, this is over. Reimer-Tiemann reaction. HCl. Okay. So we have phenol with zinc test. This reaction is important, and oxidation reaction also is important. Benzoquinone, we'll do these two. Next question. What is this? Zinc dust reaction. Na? Phenol with zinc dust. Phenol with zinc dust. Now phenol, then zinc, then heat. So simple. You are just breaking the oxygen, removing oxygen. What is removing oxygen? Reduction, a ring plus your Zn. Last reaction is conversion of, careful. Oh, one more thing is that I can just tell you. One second. If somebody is asking you, convert phenol to toluene. If somebody says convert phenol to toluene, OH, zinc, heat, it will become phenol to benzene. Then you will do alkylation, methyl chloride with anhydrous AlCl3, you get toluene. That's all. Easy? Easy. The last reaction, oxidation reaction. I don't have place here, so I'm going to just take the reaction here only. Oxidation, you take phenol, introduce sodium dichromate, sulfuric acid, you will be getting an oxidation product, that is benzoquinone. Okay, oxidation in the presence of sodium dichromate or potassium dichromate, so you will be getting, in presence of acidic medium, you get a compound called benzoquinone. Okay, so this is your oxidation, this is your reduction. Correct now? Yes, that's all. So before we'll have one more questions, we'll have a lot of big questions. We'll just take a small break and come back. Alright, now let's do the next question. Basically this is given to us and the question says A and B in the following reactions. I need to identify A and B in this reaction. Alright, they are given 4 options are given to us. Careful. First, as soon as such question is given to you, you're supposed to concentrate on the reagent. Careful. So what is this reagent? This is NaNO2 plus HCl is nothing but HONO. Correct na? It's nothing but HNO2. So HNO2 reaction, simple, it is nothing but diazotization reaction. Diazotization reaction is HNO2 reaction. Correct na? Alright, so diazotization, what does it do? Basically, diazotization reaction, it's going to convert benzene to BDC. This is my concept, correct na? BDC. Now, what is this reagent doing here? Zinc is nothing but a reducing agent. It is going to do the reduction process. So, BDC gets converted to benzene again. This is what is my concept, correct na? Yes, so I need to understand what it is A and B in the following, whether A, this one or this one, this one. So let us do the reaction. We'll do step by step and understand. We have 2 pages. So carefully we will take the reaction and understand. Step number 1, what did I do? What did we do rather? It is nothing but diazotization reaction. Careful. In diazotization reaction, the reagent is nothing but your NaNO2 plus HCl at 5 degrees centigrade. HCl at 0 to 5 degrees centigrade. So here, first step, your benzene ring C6H6, you are going to add HONO, HNO2 or H and HCl. So nothing, it simply gets converted to C6H5N2 plus Cl minus, correct, plus water molecule. This is O. So here in this step 1 case is done. So BDC, this is our compound. Okay. Then they said, first this is A part is over. Now let us go to the B part. They said the B part, or rather the next one, BDC, what did they do? They did 2 reactions in this. Okay. Here there's one more. Second one, hydronium ion or water rather. We are trying to do hydrolysis reaction here. Careful. This is hydrolysis reaction. So same one, BDC, it also has to undergo hydrolysis. That's reaction 2. So I'm going to take step 2. This is in step 2, C6H5N2Cl is undergoing N2Cl. It's undergoing hydrolysis. So what happens? The bond breaks here. Nitrogen gas escapes out. HCl is out. So what do I get? I get C6H5OH phenol plus your HCl plus nitrogen gas is out. Is it okay? What is this reaction? This is nothing but formation of phenol, but this step 2 reaction is hydrolysis reaction. Okay, hydrolysis. Okay, done. Now first one is phenol, which I got, and second one basically I took benzene and I got A, that is BDC. Then I did hydrolysis step 2. Let us still do. I didn't do completely. Then I have to do what? I have to do with zinc. So what is A now here? In this case, your A is nothing but BDC is getting converted phenol. Now this becomes A because this becomes step 2, correct? So this is not A. This is part of A and this is B, A. So now in step 3, what did they do? In step 3, I took this phenol. I use that reducing agent, that is nothing but zinc. So zinc reduction is going to happen. Reduction, that is removal of oxygen and addition of hydrogen. So you're going to get benzene back. and your ZNO is out. So this is your B part. Right, simple. So before going to this question, let me come back and answer this here. So what is A in this case? A is nothing but our phenol. Here B is nothing but a benzene. So phenol and benzene. So the option in this case, your C is the option which is correct. Correct na? So A is phenol, which I got. B is benzene, which I got. So option A and B are this. So you will write at the end, A is phenol and B is benzene. That's all. That's all. Okay, right? Okay. Next question. Let us go to the next question and understand. Write the chemical test to distinguish between the following. Okay, chemical test. So basically they've given me ethanol, okay, and propanol, butanol, phenol, propan-2-ol and pentanol, phenol and anisole. Don't get confused. First of all are alcohols. So you already studied the alcohols thing, right? So careful. So whenever you are doing, so basically remember alcohol, the distinguishing test is Lucas test. Correct now? So let us first understand carefully. First thing, let us take the first thing. Ethanol and propanol. What is ethanol? Ethanol is this versus your propanol. 1, 2, 3 and 4. Okay, so what is the difference between both of them? So basically this is ethanol and this is propanol, and that too propanol is here. If I expand, this is also the primary alcohol only. This is also primary alcohol, but ethanol, if I have to see, there's only one this group. So ethanol does not show turbidity. No turbidity. First of all, your primary alcohols, they show turbidity very, very slowly, that too heating. So this is going to show turbidity in few minutes. In few minutes is what I get. Few minutes. So basically, first test or first ethanol and propanol, how can I differentiate? I can distinguish with Lucas test, and you will write these two observations, no turbidity or turbidity in few minutes. So what is a Lucas reagent? You will be writing here. Try to write it here. Lucas reagent is ZnCl2 and concentrated HCl. This is what is important. Over. Next, what is the next molecule? They have given butanol and phenol. Okay. So here 1, 2, 3, 4 OH versus your phenol molecule. Correct na? Your phenol molecule. Now tell me, first of all, whenever you have phenol, first test, remember neutral FeCl3 test. This is the best one. So phenol is going to show neutral FeCl3 test, where when you add neutral FeCl3, this is going to turn into violet color. But when you take butanol, here there is no reaction, no color change only. So no color change. So what do? I go back and write, whenever there is phenol, neutral FeCl3 test. This is okay. Done. Next is 1, 2, 3. This is propan-2-ol. Pentan-2-ol is 1, 2, 3, 4, 5 and 3-ol. Correct na? Right. Now basically whenever you observe such, remember the molecule which or compound which does not contain, careful, the compound which does not contain CHOH-CH3 and COCH3 do not give iodoform test. Okay, the compound that do not contain such groups do not give iodoform test. Now in this case, what is the molecule here? CHOH-CH3. CHOH-CH3. Now you tell me, in this above structure, compared to both pentan-2-ol, this is CH2, this is CH2. Correct? Here in this case, propan-2-ol gives me iodoform test while forming yellow PPT. Okay, and that too, what is the reagent? Iodine plus NaOH, and here it is CHI3 formation. Now here there is no PPT at all. No PPT. According to this, there is no PPT at all. So go back Whenever you see propan 2-ol and pentan 3-ol what test, iodoform test I can comfortably do. Okay, then phenol and anisole. There is no place here, there is no place here. So what will I do? I will do here only. Phenol and anisole, when I say, they show me bromine water test. I can distinguish with the bromine water test. This one. So in this case, phenol decolorizes bromine water and anisole no reaction. So I'll write phenol decolorizes bromine water and your anisole does not. It will not show any reaction with that. Is it okay? Yes, clear? Chalo. Okay, right. So they asked me to do. I think this is clear, students. So you need to write in the exam in this way. Separately you need to write. So let us go and do the conversions now. So conversions, they asked me to do dehydrogenation of ethanol to ethanol. Correct na? Ethanol to ethanol. So first of all, dehydrogenation means I have to remove hydrogen. Removing hydrogen, which reagent? Yes, you said it right. Dehydrogenation reaction is done by or using copper at 300 degrees centigrade. Copper at 300 degrees centigrade. Now write that reaction. Ethanol to ethanol, all to al. Okay. So I took ethanol. I added copper at 300 degrees centigrade. So removal of hydrogen. This hydrogen is removed and it gets converted to ethanol. Easy. Next, phenol to benzene. Simple. See here. Phenol is here. What should I do? I have to convert this to benzene. This one. What is extra in this? It's nothing but hydrogen. I use reducing agent reduction. Zinc and heat. Hydrogen is removed and the molecule forms S and you get Z. Over. Easy. Very easy. So careful. Conversions are easy, tests are easy. Any doubt? So sorry for the confusion here and a little. I think I will erase that for you all so that you don't get confused. Something it's not getting erased. Anyways, I will go to the next. Sorry. I'll go to the next question. Okay. Next, let us read this question. An organic compound A reacts with sodium to form compound B with evolution of hydrogen gas. Good. And A gives yellow compound and C on reacting with iodine and sodium hydroxide. Okay, when they've given me a little clue that iodoform test also is happening. When heated with concentrated sulfuric acid, it forms D, which on reaction with concentrated HI at 373 Kelvin gives compound E. The compound D is also obtained when B is heated with E. Okay, easy actually. First of all, how to do this question, let us understand. C2H6O. Expand the structure and see. What is that? C2H6O. What is this? It's nothing but CH3CH2OH. Correct na? Count C2, 3 plus 2, 5, 6 and O. This is your molecule A. Correct na? This is A. I got A. Now what did they do? They said they have taken A and they have treated with sodium. And it released hydrogen gas. So when sodium is there, it forms sodium ethoxide na. So I get sodium ethoxide plus hydrogen gas is out. This is compound B. Then they said compound A gives an yellow compound. Okay. And compound C on reacting with iodine and sodium hydroxide. So compound A gives an yellow compound, means yellow means it's nothing but iodoform test na. Iodoform test. So I get CHI3. This is compound C. Now they said when heated with sodium concentrated sulfuric acid, okay, forms D, which on reaction with concentrated HI reactions are nothing but ether, means that means D should be ether. it gives compound E. So this one, it is reacting with concentrated sulfuric acid. So what does it do? It's trying to remove your water. It's trying to remove your water. So one more molecule of ethanol reacts here, and you'll be getting CH3, CH2, ether, and CH2, CH3, 2 molecules rather, it is understood. Now this is compound D. Now this ether reacts with Hi. So the bond breaks, and because it is primary, you will be getting I and simple CH3, CH2, OH. So this is compound E. Easy? Very easy. So do we have one more? Before we go to this question, let us go back and write what are there. What is A? They asked me to find A, B, C, D, E. What is E? You should write. So a solution. You have to solve this in the exam. You have to write this. You will write here. A is ethanol. Like that. CH3, CH2, OH. Then what is B? So gradually write sodium ethoxide. Write that completely. This is CH3. I am just writing the names here. C is iodoform, CHI3. This is C. Then D is nothing but ether. What is E? E is nothing but I. Okay, simple. So basically write all the names in detail, iodoform, write completely everything and then finish off the answer. Easy? Very easy. Next question. Write the structures of the main products in the following reaction. Okay, very important. See here, don't get confused or don't panic, nothing. It's easy. First of all, what you should remember, see what reagent are given to you. What reagents are given to you. In this first case, I have a place, but anyways, I'll just try to finish here. It is symmetrical alkene, correct na? Your water is getting added, that means H plus and OH minus. There is no big rule that where to add and everything. But here they said acidic medium. So careful, your negative addendum goes and adds to the carbon having less number of hydrogens and your proton positive to more number of hydrogens. So I'll be getting a compound which is next reaction with HI. One is the bulkier group, one is the smaller group. So always when you are adding to a bulkier group, yes, your bond iodine goes with the smaller group and H goes with the bulkier group. So you get phenol plus C2H5I. Now next one is what? Oxidation process with potassium dicarbonate or sodium dicarbonate. You'll be getting benzoquinones. Correct na? Benzoquinone. Sorry, this is not the thing. Benzoquinone. Then electrophilic addition reactions, bromine and carbon disulfide. You get two different products. One is the ortho position and one is the para position. That is nothing but here ortho and para. Correct na? Ortho and para. Next, the last one, Grignard's reagent. It's nothing. Basically, your Grignard's reagent will go and add to the formaldehyde, and that it undergoes hydrolysis. So, final product formaldehyde with Grignard's reagent is going to give me a secondary alcohol. Correct. So, basically, it is a secondary alcohol, if I have to tell. It's going to, because it's a no, 1 minute. CH2OH na primary alcohol, sorry, means it is going CH2OH. It's like, it's adding like this, C6H5 CH2OH, CH2OH. So here the ring is added to your formaldehyde. Easy. So directly I am going, this page is my blank page, so I am just going to the next question. Okay. Now this is again a paragraph based question. What did they give me? Phenol when reacts with concentrated sulfuric acid forms Y. Okay. The compound Y is react with concentrated nitric acid to form Z. Identify Y and Z. Explain why phenol is not converted commercially to Z by reacting with concentrated nitric acid. Now any clue here? There's a clue. Concentrated sulfuric acid, it's here sulfonation, and the electrophile is addition of SO3H. Concentrated nitric acid, that too concentrated, it is nitration reaction. The electrophile is NO2. Correct? Yes. So simple reaction. What did they say? They first said C6H5 reacts with concentrated sulfuric acid. So C6H5OH reacts with concentrated sulfuric acid. So what will happen? It will go and attack at, careful, para position. Your SO3 electrophile, this is OH, it will attack at SO3 at the ortho position and SO3 at the para position. Is it okay? Yeah, right. Now this is your first one. What is this compound? This compound is nothing but, they said the same, react with, no, the compound Y. So this is compound Y now. Y compound again is reacting with concentrated nitric acid. That's step 2. So Y compound, I am again taking the Y compound, Y with your phenol, with your SO3H at ortho, SO3H at para, Y. Now it is adding with nitrate, it's undergoing nitration, correct, and it's going to form, and that too this is concentrated nitric acid. So what will happen? Concentrated nitric acid, it is going to replace the SO3H with your NO2. So this molecule is nothing but 2,4,6 trinitrophenol, or it is also called picric acid. It is also called picric acid. Is it okay? Is it okay? So what is the molecule now? The molecule here is Z. This is Z. This is Y and this is Z. And next page, they asked me one question. They asked me why phenol is not directly converted to Z using concentrated acetic acid, concentrated nitric acid. They said why this phenol is not directly converted to Z, that is picric acid. So this is what they asked, why your phenol, why it is not directly converted to your picric acid Z, that is picric acid, in this way. Why they are asking? Okay, they are asking this, why it is not converted directly. So basically what happens when you take phenol, when you are trying to directly add HNO3, what will happen? Phenol, when you treat directly with concentrated nitric acid, it will undergo oxidation. Okay, and this oxidation process, when it's undergoing, it is highly exothermic. Lot amount of energy is released in this reaction. Yes. So if it is exothermic, that's not desirable. Correct na? So to prevent this, we first try to take phenol, we do sulfonation. After sulfonation, we try to do nitration. This is what is a reaction. Got it? So if you do this, no, what will happen? Your picric acid, whatever you're getting, the yield is very high. Yield is high. So basically the process is this. Is it okay? Yeah. Shall go back before we go to this question. Let us go back to the question and tell what is X and Y. X is your careful, not X, rather Y and Z, not X, Y. Y is your compound, the formula of the compound you are going to write, easy. and Z is picric acid. Write the molecule completely and name it. Okay, yes, write the molecule and just make it and simple. Now what is the name of this compound? This is para-hydroxy benzene sulfonic acid. This is para-hydroxy benzene sulfonic acid, and this is 2,4,6 trinitrophenol. Is it easy? Okay, sure. Next, let us do next one. We'll take a small break and then come back. Alright, now let's come back and just once again let us see whether that is okay. Let's do the conversion of the following. Alright, so basically they have given me a conversion, that's toluene from phenol. Alright, then phenol from aniline. So maximum students get confused and do it the other way. Don't do it, students. Careful, understand. They've asked me to do toluene from phenol. Let us write both before doing this question. Okay, so first thing, I want toluene. Okay, this one. Then I'm going to pick up the raw material, that's nothing but phenol. Correct na? Okay. The second one, they gave me phenol. I need to get phenol from where? From aniline. This is what is the concept. Correct na? So when you see this, first of all, toluene, or to get alkyl group, to introduce alkyl group, only method which we have is I can do alkylation. Correct? The alkylation I can only do with your anhydrous AlCl3. Correct? No? So this I need. So which compound undergoes alkylation? Basically benzene. Now you only see from phenol to benzene, what is the difference between this molecule? Hydrogen. So you'll be using the reducing agent zinc to remove oxygen and hydrogen. That's all. Simple? Very simple. Now let's go back again. Phenol. From aniline to phenol, always I said aniline, if you have, the best reaction to do is diazotization reaction, that's 0 to 5 degree, where you will be converting your aniline to your BDC. Your aniline, it's getting converted to BDC. So BDC, once you heat it with water or warm it, what happens is immediately the nitrogen which is there and HCl what is there, it escapes out and your phenol is done. So this is the simplest and the easiest method to do. Easy, students? Conversions are very easy. Actually, you need to hold the crux. Chalo. Next question. Which of the following compounds gives fastest reaction with HBr and Y? Fastest. So basically HBr. Alright. What are we doing? Basically HBr addition. HBr addition is nothing but you are adding a nucleophile, that is nucleophilic substitution reaction. At the same time, HBr hydrobromic acid is also an acid-catalyzed halogenation reaction. Acid-catalyzed halogenation reaction. Okay. Now, as you said, among all, which is giving fastest reaction? So, in nucleophilic substitution reaction, what is the concept? In nucleophilic substitution reaction, you require a stable carbocation formation. Stable carbocation formation. So, which is a stable carbocation? Stable carbocation is tertiary. So, now you go back and check which is tertiary alcohol. Among all this is tertiary. So, when you do HBr reaction, automatically it will form a tertiary carbocation replacing the bromine. That's why the option is easy. Very easy. So concept is this. So careful. Let us do one more question. Okay. There's a big paragraph here. I'll make you understand how to do it. They said an alcohol A on oxidation with potassium dichromate. Okay. So here this is alcohol because C4H10O, nothing. So alcohols on oxidation gives what? Carboxylic acid. So this is an oxidation reaction. Then after that, it gives compound B. That's fine. Compound A on dehydration with concentrated sulfuric acid. So, A compound on dehydration with sulfuric acid gives compound C. Dehydration means nothing but alkene formation, na? Okay. Then C compound gives compound C gives compound D, which is an isomer of A. Okay. Identify compound. Compound D is resistant to oxidation. So which compound is resistant to oxidation? Tertiary alcohols. This also clue I got. Then A can be easily oxidized. That means it is primary alcohol. Okay, here they have given clue. Identify A, B, C. Easiest question. Let us start solving one after the other. So step number 1 is what? They said compound A is undergoing step 1, compound A, C4H10. I got one clue here that it is primary alcohol. So compound A, 1, 2, 3, 4, C4, H10. This is your compound, correct na? This is your C4H10. Now what is it doing? It's undergoing oxidation process with which reagent? Potassium dichromate. Oxidation process. So primary alcohols on oxidation gives me simple removal of this hydrogen and addition of oxygen. So they give me primary alcohols. Can I write this all CH2s together? All basically, or if it is getting confused, 1, 2, 3, 4. Okay, 1, 2, 3, the fourth carbon, 1, 2, 3 and COOH. Alright, so basically you are getting a 4 carbon chain. Count the number of hydrogens, 3, 4, 5, 6, 7, 8. So here 3, 4, 5, 6, 7, 8, 9, 10. Okay, I removed this one, hydrogen, 1 CH3, 1 CH. Okay, so basically here there is one confusion. Confusion is this one. They said C4H10O. Okay, it gives carboxylic acid, that is C4H8O2 they said. Okay, so C4 basically is an isobutanol. It is not primary. Reason, I'll tell you why. If you take this, you will get confused with the carboxylic acid. Here you need to take an isobutanol instead of this. Isobutanol instead of this, take an isobutanol and see how we get the product. This is your molecule, this and this. Okay, now so this is isobutanol. Now since this isobutanol on oxidation with potassium dichromate, you will be getting you're just taking this out and you're adding it. Two alkyl groups I opened it, and CH and COH. What is this molecule? This is called isobutyric acid. Isobutyric acid. This is okay. So isobutanol is getting converted to isobutyric acid. Count the number of carbons here, 2, 3, 4. Count the number of carbons to 1, 2, 3, 4. Simple. So now your step number 1 or A is isobutanol. Step number 2, B is isobutyric acid. Now what happened? Compound A when dehydrated with concentrated sulfuric acid. Take that. This is your step 2. Step 2 is your dehydration reaction. Dehydration reaction. Now what is this? Your isobutanol. You are dehydrating with concentrated sulfuric acid. At what? At 443 Kelvin. So you are removing your H and OH. You are removing water molecule here and this one, and you are shifting the bond. So you will be getting plus water. This is which? This compound is C. This is nothing but isobutene. Then what did they say? They said, and compound D, which is an isomer of A. Okay, compound this is formed, and they said C is an isomer of D. Okay, step 3. Compound compound with aqueous sulfuric acid. C gives compound D, which is an isomer. Okay, so basically this one undergoes hydration now. So this becomes, we are adding water in the presence of sulfuric acid. That is what they have given now. So what happens? They said it is an isomer of. Now what are we doing? We are adding hydration reaction where the bond is broken and it is following Markovnikov addition. So you are getting tertiary alcohol. Now this and this, they said D is a tertiary butanol, rather tertiary butanol. So this is, C is isobutene. So C converting into D now, correct? So what did they say? Then next I have one place before we go to this. They said compound D is resistant to oxygen. So am I right now? Compound D, this is compound D, tertiary alcohol is resistant to oxidation, and they said compound A can be easily oxidized. Compound A, yes, this can be easily oxidized. This is compound A, yes. So write all A, B, C, D. I am summarizing everything now. Compound A is basically isobutanol. What is the formula? CH3 taken twice, CH, CH2OH. Compound B, isobutyric acid, that is CH3 CH, your CH3 and your isobutyric acid. This is compound B. What is compound C? It is isobutene. Compound D is tertiary butanol. Tertiary butanol. Easy? Very easy. Question? Carefully observe, see how I did step by step and understand the reaction. Okay? Chalo. How will you convert the following? How will you carry out the following conversions? Yes. So phenol to cyclohexanol, benzyl alcohol to benzyl chloride to benzyl alcohol, anisole to phenol. All are easy. I have one page here. I'll use this before we go to this question. Chalo. First, they said phenol to cyclohexanol. Phenol is this, cyclohexanol is this. Now you tell me, what is the difference between both of them? Yes, simple. You'll add hydrogen to this in the presence of nickel. That's all. Second one, they said benzyl chloride to benzyl alcohol. Let us draw the structure. Benzyl chloride, and they said benzyl alcohol. Now what is the difference between both of them? There's addition of or replacement of chlorine and addition of OH bond. So which one can do? Aqueous KOH can do this. So your KCl. Correct? Done. Third one, they said anisole to phenol. Anisole is here. Phenol is there. You will add HI. Ether reaction is with HI. So when bulkier groups are there, proton goes to oxygen and CH3I is out. That's all. Easy? Very easy. Let us see one more question. Oh, big question. So careful. Now first of all, when you see such, remember what is the role of the reagent. The role of the reagent is catalytic hydrogenation. Catalytic hydrogenation. Next, PCC. It is mild oxidation. B2H6. Hydroboration-oxidation reaction, anti-mark addition. Aqueous sodium hydroxide, what does it do? Basically, aqueous sodium hydroxide, it forms, means carbon dioxide also is there. It's called Schmidt reaction, correct na? Hydroboration-oxidation reaction. This is oxidation reaction rather. Okay, this is hydrogenation, this is oxidation, this is anti-mark addition, this is Kolbe. Schmidt reaction. KOH basically is nothing but nucleophilic substitution reaction. NaNO2 is nothing but diazotization reaction. Diazotization reaction. Okay, remember this before we go to the next one. I will not draw here. I'll keep this as a blank page, and you can directly write the product here. So whenever you are doing reduction, catalytic hydrogenation or reduction, aldehydes on reduction gives primary alcohols, correct na? Directly primary alcohols, the same number alcohols. This compound in the presence of PCC, one will be your alcohol and one will be your aldehyde. Okay, but the majority same thing, don't do anything, don't change the structure, take out this and add your CHO bond. That's all. Diboration, anti-mark addition, you will always get alkene to primary alcohol. Aqueous sodium hydroxide will replace the, means because it is carbon dioxide, you are going to add COOH group to this, and it is nothing but salicylic acid. Then aqueous KOH, just remove the Br group and you will be getting 2-diglycol. Diazotization reaction, careful, it converts aniline to BDC, BDC to phenol. That's simple. So remember the reagents, students, careful, reagents and their type of reaction is important. Next question. This is also blank. I already did the reactions there. Next. Name the reagents to convert or do the following reactions. So basically primary alcohol to aldehyde. Best reagent is PCC. Pyridinium chlorochromate and HCl. Butan 2-one to butan 2-all. Ketones to alcohols. So sodium borohydride, phenol to trinitrophenol. It's nothing but concentrated nitric acid, nitration reaction and sulfuric acid. Done? Done. So let's take a small short break and then join. Now let's come into the next question. So let's read the question first. Dehydration of alcohol to form an alkene is always carried out with concentrated sulfuric acid and not with concentrated HCl or concentrated nitric acid. Why? That is what they are asking. So basically this is a mechanism, correct na? Dehydration of alcohol is a mechanism. But here what are we doing? They have given you in the form of a 2-mark question. You need to answer it perfectly with wordings. Let us answer it. So basically in dehydration of alcohols, what is going to happen? Let us first understand. So basically dehydration of alcohol, nothing but your removal of water molecule to form your alkene. So in dehydration of alcohol, in step 1, don't write the mechanism, just explain them. Here in step 1 what happens, your alcohols are protonated, so there's an addition of proton, correct? Now alcohols are protonated, you're adding proton to your alcohol, this is okay. In step 2 what is going to happen, in step 2 your whatever protonated alcohol is there, that alcohol is going to lose, okay? So protonated, you just write like this, protonated alcohol will lose water, correct? Now that is what is lose water, so that is what is the purpose. Then once it loses water, it's going to form alkene, correct? Now so to lose water to form an alkene. Now what is happening here, this all is happening in the presence of concentrated sulfuric acid. Concentrated sulfuric acid is trying to remove water by dehydration process, that's why I'm using. But now what happens, suppose if you are using HCl, now just you are explaining the case now. Suppose if HCl is used, HCl, what is the purpose? HCl is a strong nucleophile. Then what happens when it is a strong nucleophile? It is going to cause nucleophilic substitution reaction. Here what is happening? We want dehydration, but it will call nucleophilic substitution reaction. That's why I am not using HCl, because it is a strong nucleophile, it causes nucleophilic substitution. Hence HCl is not used here. Now what happens if HNO3 is there? If you are taking HNO3 is also a strong oxidizing agent. So what will it do? It is going to cause your oxidation process. But now what is happening? You want dehydration process, but HNO3 will do oxidation, HCl will do strong, it will do NSR. That's why HNO3 is also not preferred. It is also not preferred. So you write here simple words. Concentrated sulfuric acid is going to go allow, and it will do dehydration. Your HCl is used, it will form NSR, nucleophilic substitution, and your HNO3 whatever is there, it will go and do oxidation process. That's why I don't prefer HCl or HNO3. Is it easy? Very easy. Next question, let's see this. Write the structures of the major products of the following. Mononitration of 3-methyl phenol. 3-methyl phenol, it's okay. I will use the first one here. Mononitration of 3-methyl phenol. Take 3-methyl phenol, you have your OH bond here. This is 1, this is 2, this is 3. So methyl group is here. Now what are you going to do? You are going to do mononitration, they said. So you'll use a nitrating mixture, HNO3 and sulfuric acid. What is an electrophile here? NO2 plus. So mononitration means it will form both the products. You need to draw both the products. One product is your OH group, okay, and your CH3 is here. Now one will form the nitro group. At the same time, this will also form mononitration product. One is major and one is minor. One is your CH3. See this. This is para, and now it is your NO2. This is your ortho. So both the products are formed, and both are formed in this. So one only substituted. Easy. Next, then they said dinitration of 3-methyl phenol. Okay, second one I am doing dinitration, means two products they are saying. Dinitration means two same molecule. Okay, you are using same 3-methyl phenol. Now you are doing dinitration. Nitrating mixture is the same, but now here there are two substituents, rather 3 substituents. This is CH3 here, one at the ortho position and one at the para position. This is your dinitration product. What is the last one they have given me? Mononitration of phenyl ethanoate. Mononitration, easy. So mononitration, nitrating mixture is the same. Of which one? Phenyl ethanoate. Phenyl, okay, the group is this, and ethanoate is OCOCH3, correct? Now I need to do same nitration mixture, mononitration, which is stable compound, para is stable, so I am going to nitrate it at the para position. Mononitration. Easy, very easy. Question is easy, question clear? Chala. Next question, let us go to write. Give equations for the following reactions. Bromine and carbon disulfide, treating phenol with chloroform in the presence of aqueous NaOH, oxidation of propan-1-ol with alkaline K-4. Easy. First of all, bromine With carbon disulfide, what is this? It is nothing but electrophilic reactions where bromine is added at the ortho position and para position. Okay. Treating phenol with chloroform in the presence of NaOH is nothing but your Reimer-Tiemann reaction, correct na? It is your Reimer-Tiemann reaction. Okay, this also I can do. Then oxidation of KMnO4, okay, oxidation, you very well know, oxidation is given to me. Let us do first one here, carbon disulfide. You're going to take your phenol. So remember students, whenever you're doing, try to name the molecule. This is very important. You're adding bromine. Now what you're taking carbon disulfide. So both ortho position and para position you're going to get. So one is phenol at your ortho position. One is phenol at the para position. Phenol at the para position. This is okay. Done. Okay. Over. Next, treating phenol with chloroform in the presence of aqueous NaOH. Okay. Second one, you're treating phenol with what? You're treating phenol with chloroform. Okay, chloroform in the presence of NaOH at which Kelvin? 343 Kelvin. What is the reaction? Reimer-Tiemann reaction. Correct now? I am writing the shortcut. Now what will happen? Basically in Reimer-Tiemann reaction, you are getting salicylaldehyde. But here you are going to write the molecule. You can write the molecule in this way and leave it so that they know what substituents are there in that. Okay. Yes. So Reimer-Tiemann reaction. Careful students. And that thing what you should do is what you should do is careful. You should show both the product. That means why I should show both. The examiner will be clear of what transition, what intermediates it's forming. Okay, you can leave the compound here, then too you'll get full marks. What is the third one? They said oxidation of propan-1-ol. Okay, propan-1-ol. 1, 2, 3, 4. This is propan-1-ol. If you don't know, you can write like this: propan, 3 carbon atoms, 1-ol. What am I doing? I'm using alkaline KMnO4. Alkaline KMnO4. What does this do? Oxidation process. So in oxidation process, as you all know, addition of oxygen to this molecule and removal of hydrogen. Hydrogen is removed, oxygen is added to this. Correct? So what do you get? You get COO minus K plus. You can also write acid directly, carboxylic acid you can write. I'm showing the examiner that this is the intermediate state, because here give equations of the following. I can write the final product, salicylaldehyde here, I can write the carboxylic acid here, but problem here is I want to show the examiner the intermediate. If I leave here also it's okay. If you want to further write also it's okay. You can write like this also, it's okay. Got it? Right, got it. Next question. Describe the following reaction with examples. One is Kolbe's reaction, one is Reimer-Tiemann reaction. So next, before we go to this question, let us rock it. Now first reaction is Reimer-Tiemann reaction. R-I-T, Reimer-Tiemann reaction. First of all, in Reimer-Tiemann reaction, okay, here students, if you want, ma'am, how can I write the final product? Okay, you write the final product also if it is bothering, because I want students to understand what did I write. Okay, done. Correct na? Chalo. In Reimer-Tiemann reaction, first I am going to take phenol. Okay. Into this phenol, what are you introducing? You are introducing chloroform and you are introducing sodium hydroxide. At what Kelvin you are introducing? At 343 Kelvin. Correct na? So what will happen? You will be getting first O minus and Na plus. Correct? Then your CHCl2, which is an intermediate. Further, you are going to introduce your sodium hydroxide and you will be getting, okay, I'm directly writing it, students. I did one short videos. I have explained each and every molecule. I did explain as a classroom teaching. I explained why is the intermediate formed, what is happening inside the molecule and everything. So please go and watch the video, one short videos in detail explanation I did. So this is your formation of salicylaldehyde. Correct na? Now this is your Reimer-Tiemann reaction. Now the second one, Kolbe's reaction. So Kolbe's reaction you can start from here. So basically in Kolbe's reaction, O minus Na plus, You're adding carbon dioxide to this at which Kelvin? 400 Kelvin at 4 to 7 atmospheres. So your reactions O minus Na plus COO Na. I'm just writing again. I'm mentioning, students, I have done this mechanism in detail in your one-shot videos like classroom teaching. So finally, in Reimer-Tiemann reaction, I am getting salicylaldehyde. In Kolbe's reaction, I am getting salicylic acid. Correct na? Both. So Reimer-Tiemann reaction will give salicylaldehyde, and Kolbe's reaction will give me salicylic acid. Easy. So please watch one-shot videos for detailed explanation. Next reaction, next question. Which of the following is an appropriate set of reactants for the preparation of 1-methoxy, 4-nitrobenzene and Y? Okay. Which of the following are appropriate set for the set of reactants? Okay. So what they said? For the preparation of 1-methoxy, 4-nitrobenzene. Okay. And Y? What are there? So I should prepare 1-methoxy, 4-nitrobenzene and give it to the examiner. Okay, 1-methoxy, 4-nitrobenzene. Okay, sure. Now, first of all, in this reaction, first, these are haloarenes, na? Yes. So what happens in the haloarenes? Which of the following? They didn't give me any options here. Which of the following means I should think and understand. First of all, I need to prepare this molecule. Okay, this molecule, and I need to form methoxy, okay, and nitro group. This is what I have to prepare. Correct, na? Methoxy and nitro group. Now you tell me, to get this methoxy, I have to go back and form, or basically this is an ether, na? So I need to take a molecule which has NO2 group and a halogen, because when I add an less bulky alkoxides, what happens here? It is a bulky group and this is a smaller group. So to get this ether, I need to take a smaller, bulkier group so that the bond breaks and CH3Br is out. Correct, na? This bond breaks and CH3Br is out and ONA plus comes in. Then this ONA plus molecule, what happens further? NO2 plus your ONA plus. I further add CH3Br. Again the NABr breaks out and you will be getting this molecule, isn't it? NABr is here in this case, NABr here in this case, and I get. So the exact haloarene, they undergo nucleophilic substitution reactions in drastic conditions. So careful, as I said, easy, the molecule you're further breaking and giving it to form this. Okay, this is the molecule rather. This is the molecule. Next question. How will you distinguish between methanol and ethanol? Oh, easy question basically. First of all, methanol and ethanol. How can I? First of all, we'll try the structure and see, and I'll give you what options. First of all, CH3OH is here. I will make CH2OH, ethanol and methanol. First thing, when I take alcohols, I'm testing it with iodoform test. INaOH. This is your iodoform test. What happens when you add methanol to iodoform? There is no LOPPT. Okay, it does not respond. It doesn't form iodoform to this, because look at the functional group. But here, because of the presence of this alkyl group, it forms an LOPPT. What is that? CHI3. Done. This is one differentiation. Next, you have one more test called sodium metal test. Because metal, when you add metal, because alcohols act as acids. Correct, na? We told alcohols act as acids. So when it reacts with metals, when it reacts with metals, what happens? This and this both give reactions. Both will have effervescence. Hydrogen gas is liberated, na? Yes. But here, this also gives hydrogen gas in the form of effervescence. But the reaction of methanol with sodium metal is less vigorous. But in this case, here also hydrogen gas is released. Here the reaction is more vigorous. Is it clear, students? I'm just drawing a line, very bad line, but anyways, this is one test, this is one test. Third one, I can use acidified potassium dichromate, means I am trying to do oxidation. So on oxidation, what happens? Methanol on oxidation, it forms formaldehyde. Then this further forms formic acid, HCOH. Ethanol on oxidation, it's going to form acetaldehyde. This further oxidation forms acetic acid. Easy? Very easy. Clear? So how will you distinguish between methanol and ethanol? So 3 tests. This is the first test, second test and third test. Remember this and go. They may ask you this question. Chala. Next question. Write the reactions and conditions involved in conversion of propene to propanol. Propene to propan-2-ol. Okay. So what is the difference between this one and this one? There is addition of your water molecule, correct? That means you are doing hydration reaction. You are adding water. What reagent is required? You require hydration, dilute sulfuric acid at what Kelvin? 443 Kelvin. Correct. Next, phenol to salicylic acid. Okay. So phenol to salicylic acid is nothing but your, careful, we just now prepared salicylic acid, Kolbe's reaction. So your phenol to carbon dioxide, this one, the reagent is added and finally forming, this is your Kolbe's reaction. Correct na? Chalo. Let us do the first one, propene. This is my propene. I am adding water to this. The bond breaks. Correct na? This bond, alkene bond breaks. I am using the reagent dilute H2SO4. What am I using? 443 Kelvin. It directly goes and adds to this bond and I am getting an alcohol. Correct na? Yes, simple. Next thing, phenol to salicylic acid. Phenol, you are adding carbon dioxide, you are adding sodium hydroxide and you have 4 to 7 atmospheres. So what will it form? It will form an intermediate, sorry, I am writing with my bare hand, so that's why the structures are bad. Then further you are doing hydrolysis and you will be getting salicylic acid. Okay, done, easy. Next question. Why separating of ortho and para nitrophenols by steam distillation? Name the isomer which is steam volatile, give reasons. It's a quite common question, as we said. Basically, orthonitrophenol, it has intermolecular hydrogen bonding or intra. Yes, this has intramolecular. Okay, intra, within the molecule. This is within. Hydrogen bonding is within hydrogen bonding. Correct na? Intramolecular hydrogen bonding. When you take para-nitrophenol, it has between, correct na? Intermolecular H bonding. And that is between. It is between the hydrogen, between the molecules, between. Now, what happens is, this is like, breaking the bond within is easy compared to breaking the bond between, correct na? So this is within the molecule. That's why I can quickly break the bonds and I can make it steam volatile. That's all. Yes. Next question. Give one reaction of the alcohol involving cleavage of CO bond and cleavage of OH bond. Simple. So the first reaction, I am taking cleavage of CO bond. There are a lot of reactions, PCl3, PCl5. So take one alcohol, add one PCl3 or PCl5, your wish, or SOCl2. So OH is replaced by your Cl. Then that is what they ask now, carbon oxygen bond. Then your HCl is out. Now one reaction involving OH bond cleavage. In OH bond cleavage means basically OH bond is cleaving means hydrogen gas is released. Hydrogen gas is released means compulsory you're taking a metal solid. Then automatically your ONA is out and your hydrogen gas is out. Simple? Very simple. Next question. Account for the following. Phenol has a smaller dipole moment than methanol. Okay, phenol has a smaller dipole moment than methanol. 1 second, students. Yes. 1 second, sorry, just got a call. Okay, account for the following. Phenol has smaller dipole moment than methanol. Phenol undergoes electrophilic substitution reactions faster than methanol. Correct, na? What are they asking? Account for the following means they're asking you to give reasons. Give reasons for this. Now, dipole moment. 1 second, student. 1 second. I don't know what is happening. Dipole moment. What do you talk? Basically, dipole moment is nothing. Formation of two poles. Correct, na? So in phenols, when do we get two poles? Because of delocalization of electrons. Correct, na? So exactly use that word. Phenol has smaller dipole moment than methanol because, simple, due to delocalization. Delocalization is nothing but movement of your pi electrons. Na? Delocalization of electrons. Of which one? Of oxygen in phenol. Of oxygen in phenol. Correct, na? So what, when the bond breaks in this oxygen, yes, in this way, so when the bond breaks, so automatically 1, 2, 3, 4, 5, 6, 7, 8. So these electrons keep moving around. It gets delocalized in the ring. So because of this, what happens? It has smaller dipole and it is distributed in the ring. That's all. That's all. Phenol undergoes electrophilic substitution reactions faster than benzene. Okay. So basically electrophilic substitution reactions means they should be some electron rich means it should be electron rich. That's why electrophile comes and takes the position in the particular ring. Correct? Yes. So what happens in case of phenol, you have your OH bond. Correct. Now what happens? This OH bond, it will activate the nucleus. What does it do? I have this benzene, I have this phenol. Now compared to both of them, when this bond is broken, all the electrons whatever are there, it starts going or it undergoes delocalization of electrons inside the ring. So what will it do? Because of the plus R effect in phenol, the whatever benzene ring is there or the phenyl nucleus is there, phenyl nucleus is activated. Plus R effect. Correct, na? Because of this activated, so what will happen? The electron density is more in this. Hence electron density is more in phenol. Electron density is more in phenol. Understood? Got it? But in case of benzene, there is no substituent. There is nothing. Correct? So that's why phenol is more, means it undergoes more electrophilic substitution because there is a lot of electron cloud and electron density inside the molecule. Correct, na? Here you will write no substituents. That's easy. Next question. Complete the following reactions. Okay, so first of all, it's neutral FeCl3 test. Na? Neutral, okay, they've given aqueous FeCl3. Okay, so basically when you see that aqueous FeCl3, I'll just give you nothing. Your hydrogen and your chlorine. Careful students, your hydrogen and your chlorine molecule comes out as HCl. What is left now? What is left now? It forms a coordinate complex where the metal atom reacts with your C6H5 and your oxygen at +3 state. Yes, this is -3 state. It's -3, the valency, because this is +3, this is -3. Let me erase this. Now in the comment section you will tell me what is this molecule called. The comment section, please tell me what is this molecule called. Okay, so I just give you, tell me in the comment section, I'll pin your comment. Okay, next one, chloroform sodium hydroxide. What is this reaction? This is nothing but Reimer-Tiemann reaction, correct na? So what does it form? Your phenol is going to get converted to your salicylic with your byproducts as salt and water, correct na? So name it. Salicylic is the structure. Next, bromine, aqueous bromine. Okay, it is not carbon disulfide. If it is carbon disulfide, you will get ortho and para. Now in aqueous, what do you get? You are going to get OH, your bromine, your bromine, your bromine. 2,4,6 tribromophenol plus water molecule plus HBr. Correct. Now ONA. Okay, ONA. What is this reaction? This is nothing but Kolbe's reaction. Correct. Kolbe's reaction. So what does Kolbe's reaction form? It forms salicylic acid. Correct na? It hardly takes time. Reimer-Tiemann forms salicylic and Kolbe's reaction forms salicylic acid. Correct na? Kolbe's reaction forms salicylic acid. So careful. So simple. Next reactions. Okay, this place is blank because I already did the reaction. Let us go back to the next page. Write one chemical reaction for illustrate the following. Reimer-Tiemann reaction already done. We have done the Reimer-Tiemann reaction. Please check the earlier slide. Now Williamson ether synthesis. So before we go to this reaction, now careful. So Williamson synthesis, they didn't give me anything, they just said Williamson synthesis. Ma'am, this is ether reaction, but then too I'll do it. So Williamson ether synthesis, first thing, there are different conditions, whether you're taking bulkier alkyl halide or bulkier alkoxide. So when I do the ether concept, I'll explain in detail. But as of now, in Williamson synthesis, you are taking one second students. Williamson synthesis, you are taking one alkoxide, okay, then you are adding one alkyl halide. Whenever it is, careful, whenever you are adding a bulkier alkoxide, always the alkyl group goes and adds to this, your NABR is out. Whenever you have a bulkier alkoxide, it's going to form, methyl group forms an ether with NABR out. Easy? Very easy. Remember, when I do ethers, I'll explain in detail all these. Simple. Chalo. Next question. Okay, they're just asking me to do the conversions. Okay, now predict the reagent only, they asked me. I will write only the reagent. First thing, phenol to benzoquinone. Which type of reaction this is? This is oxidation reaction. So oxidizing agent is nothing but sodium chromate or sodium dichromate in acidic medium. Over anisole to para-bromo-anisole, only para position. So compulsory, what is this? You are adding an electrophile, correct na? You are adding an electrophilic reactions rather. So, and that too, when you are doing the electrophilic reactions, one second students, I'll just take this call. One second, sorry. Okay, so basically what happens is your electrophilic reactions in anisole. So normally what happens, they will give you at the ortho position and para position. It's open for at the ortho because electron density is more. So it's going to show electrophilic substitution reactions. So for electrophilic substitution reactions, I'm going to, because they said bromo, right? So I'm using bromo in the presence of acetic acid. Third one, phenol to 2,4,6 tribromophenol. It's the same thing. We are doing substitution reactions, so it's going to form bromine or aqueous bromine rather. You can write bromine aqueous bromine or bromine in water. Easy? Easy. Next question. Out of tertiary butyl alcohol and N-butanol, which will undergo acid-catalyzed dehydration fast. Wow. Acid-catalyzed dehydration means you are trying to remove water from this, and why? Alright. So tertiary butyl alcohol and N-butyl. Let us write both. Now this is your butyl group, correct? And you have your alcohol. And now how many butyl they said? So there is one more in this butyl. 4 carbon atoms, CH2. Here they said N-butanol, N-butanol. This is also okay. Now which one will go acid catalyzed? First of all, in acid catalyzed dehydration, there is a formation of carbocation, correct na? Yes, there is a formation of carbocation. So what will happen when there is a formation of carbocation means it compulsory forms a tertiary carbocation in the step 1, 3-degree carbocation, and this in the step 1 this is going to form primary carbocation. Which is more stable? This is more stable and this is more stable. So because of the formation of tertiary carbocation, tertiary butyl alcohol will undergo dehydration fast. Will undergo, you'll write here like this, because it forms tertiary carbocation which is stable. This forms or this undergoes dehydration faster. Dehydration faster. That's all. Easy? Very easy. Chalo. Next question. Write the steps involved in the conversion of phenol to anisole. Very easy. Phenol is this. Anisole is this. Anisole is your aryl ether. Now compared to this and this, what is the difference? There is an alkyl group which is released. So first of all, always try to convert phenol to its phenoxide ion. Why? Because this is very stable form of phenol. Then you simply add CH3I. Now see here, I said if there is a bulky alkoxide, your alkyl group goes and attacks this. So your NaI is out and your anisole is prepared. See? Very easy. Next question. Why does phenol not undergo protonation easily? Why it doesn't undergo protonation easily? So when phenol is undergoing resonance, there is a positive charge in this resonating structure, na? Correct na? Already when this one, what happens here? This is like the bond is like this. Let us assume phenol. Okay, the bond, this is breaking. So what happens? There is a negative charge and there is a positive charge. So this keeps moving, correct na? This keeps moving, or the molecule again. I should write here the bond. 1 second. Okay, let us draw the phenol structure again. Okay, so the bond in this way. What happens? Double and double bond. This shifts. This shifts. This shifts. In this way, it shows resonating structures. So when it is showing resonating structures, there is a positive charge in the resonating structure, correct na? Negative and then one positive, then negative. So because there is a positive charge, there is a positive charge in resonating structure, it doesn't undergo, that's why therefore it does not undergo protonation, easily. That's all. It does not undergo protonation easy. Easy. Next question. Which test is used to distinguish between phenol and benzyl alcohol? Okay, so simple. whenever you see phenol, you need to just think about this test. Okay, in case of phenol and in case of benzyl alcohol, careful, neutral FeCl3 test, phenol gives violet coloration. I think this is the clue for the earlier one. Yes, and here no coloration. So whenever you see this, this is the best test to discuss. Okay, so neutral FeCl3 request FeCl3. I think this answer is already given. I mean, question I asked to you tell me the answer, I'll pin it. I think the answer is here. Next question. Why boiling point of ethers are much lower than those of alcohols of comparable mass? So this is your alcohol. Okay, RO. Basically, let us take one alcohol. With example, we'll take CH3, CH2OH, CH3O, CH3. Now how many carbons are there? Okay, so in this case and in this case, what is the difference you're observing? Here you have hydrogen bonding formed. Correct, na? Here no hydrogen bonding. This is a functional group. No hydrogen bonding. Here hydrogen bonding, oxygen part and hydrogen part. So here hydrogen bonding is observed. Now you tell me, when the hydrogen bonding is there, boiling point is more. Here boiling point is less. Sorry students, I think the writing pad little bit bothers me. Sorry. So boiling point is lower. That's easy. So note it. Easy. Next question. Which alcohol contain the OH group attached to sp3 hybridized carbon atom next to aromatic ring? Okay, so my pen, I don't know why it has become dark. I need to just check my settings. This one, na? So what is this? This is nothing but benzyl alcohol. So these are all single bonded atoms now, and the hybridization here is sp3. Next question. How is acetone obtained from 2-bromopropane? Okay, did I do something? Okay. How is acetone obtained from 2-bromopropane? Okay, let us write the solution part. Acetone obtained from 2-bromopropane. First of all, let us write 2-bromo. This is my 2-bromopropane. Then what should I prepare? I have to prepare acetone. I have to prepare acetone with this. Okay, acetone. Now you tell me, compared to this and this, what is the difference? Here bromine is there. Here there is an introduction of your oxygen atom. That means there is somewhere I need to remove or replace bromine and add oxygen. Okay, let us replace bromine. Simple. I am going to use the basic substitution reaction where I replace the nucleophile, bromine goes and OH comes in. So what do I get? I'll be getting your basic secondary alcohol. Now compared to this and this, hydrogen is extra. So I will try to remove the hydrogen. I'll try to remove the hydrogen using copper. At what? At 573 Kelvin. So hydrogen is removed. Hydrogen dehydration rather. This one is doing dehydration. When I remove dehydration, you'll be getting this. So this is your acetone and this is your 2-bromopropane. Okay, 2-bromopropane. Done. Next question. What is the significance of pyridine in the following reaction? So basically pyridine. Alright, so I will not tell this. I want any student to give me answer in comment section. I want to see how many are studying, how many will give me answers. I'll just take their name and pin the comment. I will pin the comment. Give me the answer in the comment section immediately. Alright. Chalo. Next question. Predict the major product of acid-catalyzed dehydration of 1-methylhexanol. So, I am going to take 1-methylhexanol. At the first position, you have CH3. At the first position, you have OH. Now, what am I doing? I am doing acid-catalyzed dehydration, means I want an acid, H plus ion. I am going to heat it. So, what will happen in acid-catalyzed dehydration? Simple. The concept is here alcohol getting converted to alkenes in the presence of H plus ions. Now simple, take out the water molecule, take out the water, this acid will take out the OH molecule, the water molecule, and the bond shifts here. The bond shifts here. So you will be having CH3 and double. That's all. This is a major product. That's all. Major. Next question. How will you get benzoquinone from phenol? Phenol, it's nothing but an oxidation reaction. So take your phenol, use your oxidizing agent, acid catalyzed, you'll be getting benzoquinone. Easy? This is your benzoquinone. Next question. Explain Reimer-Tiemann reaction. This is already done. Explanation reaction is done. So please check the earlier slides. Next one. How will you convert ethanol to ethene? So always whenever somebody is asking you to convert ethanol to ethene is nothing but acid catalyzed hydration. So my writing pad again is bothering me. Sorry students. One second please. Sometimes it bothers. So I'll take a just small break. I'll set my writing pad and then come back. Alright, now let's do the next question. How do you convert ethanol to ethene? So basically this is a conversion of alcohol to your alkene. So always alcohol to alkene is done by a method, nothing but dehydration method, correct na? So dehydration, you're removing water molecule from that and you are trying to form an alkene. Dehydration method. Okay. So what do you require? What is a dehydrating agent? Concentrated sulfuric acid at 443 Kelvin. This is the rule, right? So simple. So I'm taking your alcohol. So then what am I doing? I'm using concentrated sulfuric acid. At 443 Kelvin, what happens? This water molecule hydrogen and water molecule OH is removed and this forms an alkene. See, 2 carbon atoms now, 1 and 2. So 2 carbon atoms, you'll be getting an alkene and water is formed. Simple? Simple. Next question. What happens when CH3COH is heated with red phosphorus and HI? Okay. So basically they are giving me an alcohol. Okay, right. Then you're adding HI. Alright. Then there is red phosphorus formed. Okay. So what is the role of red phosphorus? Basically it will help in formation of an hydrocarbon, okay, and iodine gas is released. So when red phosphorus is there, the alcohol or whatever alcohol is given, the particular thing, water comes out and it forms an alkene and iodine is released. Remember this. Easy? Next question. Complete the following reaction. Okay. So concentrated nitric acid and concentrated sulfuric acid. These two are what? These two are nitrating mixtures. So what will they do? They'll go and add here all the three, because they are strong acids. They will go and occupy all the three positions, that is 2,4,6 trinitro Phenol. 2,4,6 trinitrophenol. They're going to add all both and form this. So you'll name the compound 2,4,6 trinitrophenol. Okay, done. Next question. What nitrating mixture is used for mono substitution of phenol? Now just now we did. Here we took 3. So we took concentrated nitric acid. Here we're doing only mono substitution. Only one nitro group is formed. Either your ortho position or your para position. And that too, para is stable in this case. For if you want the position of this, you are going to use dilute HNO3. Easy? Easy. Now name a compound which is used as antiseptic as well as disinfectant. Antiseptic and disinfectant, nothing. It's nothing but solution of phenol. Okay, solution of phenol. So in solution of phenol, you'll be getting there is 0.2% antiseptic in this and 0.2% disinfectant in this. Means 2%, 0.2 and 2% disinfectant. So you just write this. What is the solution? You just mention this is NF. Okay. Next question. The product C in the given reaction. Okay, nice. There are 4 options given here. Now this is sodium phenoxide. That means before this you have phenol molecule which is forming, or basically a phenol in the presence of sodium hydroxide. So they are asking me to tell only C part. Only C. So I'll show you the reaction, so it's easy. So see this reaction. First, your phenol is getting converted to your sodium phenoxide. It's basically Kolbe-Schmidt reaction, now students. This one, this part, whatever is there, is called Kolbe-Schmidt reaction. So whenever you're seeing carboxylation of sodium phenoxide, this is called Kolbe-Schmidt reaction. Okay, careful. So this part from here is called Kolbe-Schmidt. So first the sodium phenolate or sodium phenoxide is going to form 2-hydroxybenzoic acid or salicylic acid. Correct? It's going to form salicylic acid. Salicylic acid. Now that salicylic acid, now till here this salicylic acid, this part, this B part, but they're asking me C part. So the salicylic acid, further they are introducing AC2O. What is this AC2O? This is nothing but acetic anhydride. Acetic anhydride. What is this acetic anhydride? It is nothing but your CH3CO taken twice O. Or it's simply, basically, it is like this acetic group. You would have studied the acetic anhydride in this way. So you are adding acetic anhydride to this. Then what happens? The bond breaks. This here, CH3COOH. This bond breaks here, and the remaining CH3COOH, the bond breaks, and the remaining molecule, whatever is there, it goes and adds here. Careful. See here, this part, this H, this CH3COH, this part. So the remaining OCH3 goes and adds here. So this molecule, the last one, whatever is formed, this is called acetyl salicylic acid. This is called acetyl salicylic acid, or the other name given to this is aspirin tablet. Aspirin, acetyl salicylic acid or aspirin. This is my C molecule. Okay, so C, go back. What is this? See this. Acetyl salicylic acid. So the option A is C here. So what is the B option here? Basically, B option is B option is your salicylic acid, and C option is your acetyl salicylic acid. Okay, chal. This is salicylic acid, and this is acetyl salicylic acid. Okay, done. Next reaction, quickly. Chalo. Next reaction. Write the reagents for the following. Which of the following reactions can be used for the preparation of alkyl halides? Which of the following reactions? Okay. So used for the preparation of alkyl halides. So basically, first reaction is primary alcohol. Second is a primary. Third is tertiary. Fourth is secondary. Okay. So you very well know anhydrous ZnCl2. What is that? That is nothing but Lucas test, correct na? Anhydrous ZnCl2. Now, in anhydrous ZnCl2 HCl, we very well know Lucas reagent test, which will give me turbidity first among everything. Basically, primary 1 degree and 2 degree alcohols, what do? They react with HCl, and also they need anhydrous ZnCl2. As you have seen, see this is secondary, it is requiring HCl and ZnCl2. This is secondary. Here also primary, it requires HCl and ZnCl2. This is 1 degree, correct na? Yes, this and this both are same almost. So here in tertiary, there is no tertiary, doesn't require HCl, it doesn't require anhydrous, it directly, correct na? So what do they say? Which of the following reactions can be used for the preparation of alkyl halides? If I have to say 1, 3 and 4. 1, 3 and 4. Option D. Why? 1 degree and 2 degree alcohols. See, first thing this also gives, but later slowly it gives turbidity. Correct na? Slowly. So 1 degree and 2 degree. First one 1, 3 and 4. Correct na? In this case, what happened? They didn't give me any reagent, so it's very difficult for me to form product. So tertiary will form immediately. Then, as you know, the order. Correct na? So 1, 3 and 4 only, not 2. Okay. Next question. Which of the following will not be soluble in sodium hydrogen carbonate? Okay. So basically, they have given 2,4,6-tribromophenol, benzoic acid, orthonitrophenol and benzene sulfonic acid. So among all these compounds, which one is a weaker acid? This orthonitrophenol is a weaker acid. Compared to weaker acid than HCO3 minus ion. Okay. So remaining all are stronger acids, because this is electron withdrawing group, this is acidic group, SO3H also. So compared to all, because this is a weaker acid, orthonitrophenol, see this, acid plus NaOH. Normally what does it give? It gives sodium salt of acid, correct na? Sodium salt of acid. This should be soluble. Next, H2CO3 is out. Now among all these, what happened? As I said, orthonitrophenol is weaker acid. So that's why it does not, weaker acid, it does not react, or it does not react with sodium bicarbonate. Okay, so option C. Okay, sure. Next question. In the following sequence of reactions, CH3Br, KCN, and this is given, what is the end product? They are asking me end product. So first of all, in the first reaction, do I have place? I have place in the next page. I will use this before I go. This is the last slide. With the chemical reactions, this is the last slide, students. So let's see. So now, what did they give me? First CH3Br. Okay. What am I using? KCN. What is this? This is nucleophilic substitution reactions. Bromine is replaced by Cn. So CH3Cn. So what is this? This is A. Then what did they do? They have taken, okay, in the presence of H3O+. Then what are they doing? Yes, this undergoes oxidation. So it forms, this is B. Then further, they have introduced LiAlH4. Reduction is going to happen. This is a reducing agent in the ethereal solution in the ether. So acids on reduction. Reduction means you're adding hydrogen. You're removing oxygen and you're adding hydrogen. They become alcohols. Reduction. So this is C. This is C. Okay. Chalo. Go back. What is C in this case? Basically, C in this case is ethyl alcohol. Okay, got it? Sure. Now students, perfect. We have, what did we do? We have still now done everything. Every topic is done. We're starting from your classification, nomenclature, preparations, physical properties, chemical properties, everything of alcohols and phenols is done. Correct na? Phenols. Now we are going to do ethers. Yes, we are going to do ethers and anisole. Both we'll do, and we'll finish off the chapter. and I'll also should give you the mechanisms. Okay, I'll do one video on mechanisms. Alright, let's meet with ethers. Alright, now welcome back. Let's start the next chapter, the next topic rather. That's nothing but your, one second, let me close this. Okay, we are going to start with your ethers topic. So basically this is the last part of the chapter, right? Yes. So till now we have done topic wise discussion along with lot of questions, different varieties. Now we're going to start this topic. Please understand, in ethers you will be given maximum paragraph based questions. Paragraph based questions means what? You will be asked find out A, B, C, D. Means basically they'll be giving a question where you are asked to find out A, B, C, D, different reactions, different types of questions. I'll be explaining that. So watch the video till the end. Now basically ethers, if I have to start, as I said, this is a summary for you to study during the exam. Ethers basically are prepared by two methods. One, by dehydration of alcohols, and second is Williamson synthesis. I'm going to explain in detail both of them. But what is important here is dehydration of alcohol, temperature and the reagents are important. See here, when I'm taking alcohol, when I'm trying to remove dehydration, that is your water molecule, at 443 Kelvin it's going to form an alkene. This is what is important. At 413 Kelvin it's going to form an ether. So we are going to study this reaction careful, and that too with the mechanism. There is a mechanism for this which we are going to study. Next comes your Williamson synthesis, where I am going to explain you all the conditions what are there, and this is also important because maximum questions will come from this topic. Maximum questions, maximum MCQ questions rather. I'll explain this also. Alright, so let's start. So first thing is dehydration of alcohol. So dehydration of alcohol, what is the reagent I'm using? Whenever I am trying to prepare ether, if I am taking alcohol, if I have to remove water, I am going to use one reagent, that is concentrated sulfuric acid. Okay, right. This concentrated sulfuric acid, as we said, 443 Kelvin or 413 Kelvin. So simple. If I am trying to use if I am trying to use alcohol, and that too I am using concentrated sulfuric acid, and 443 rather, it is 170 degrees centigrade. At 173 degrees centigrade, what is going to happen? Hydrogen from here and OH from here is removed and you get an alkene. Correct? Now this is not a preparation. We have to prepare your ethers. So what happens? Basically your CCCH2COH. Suppose if you are taking your concentrated sulfuric acid and you are taking or maintaining 140 degrees centigrade, that is 413 Kelvin, then you will be using two different alcohols. Remember that, two different alcohols. So what happens? Hydrogen from here and OH from here is removed and you will be getting an ether. Diethyl ether is what you get. Okay, this one is the condition. Now what is this mechanism? Basically, when I see the mechanism, careful, first thing is your alcohol. Okay, so what are you taking? You're taking an acidic medium, that is your H plus ion. So step number one, careful, this bond, whatever is there, your OH or the oxygen is going to drag this bond. It is going to drag this bond. So when it drags the bond, what happens? Basically the CH3CH2OH, correct na? I told you oxygen is going to drag this bond and this gets a positive charge. So basically this whole thing gets a positive charge. This one, this part. Then what happens? You are going to introduce one more alcohol which has a lone pair of electrons. So when the bond is broken, what will happen? This becomes lonely, right? So this OH goes and attacks this C2H5. Then automatically your bond, there is a positive charge on your oxygen atom. Then does this be there like this? No. So the proton is eliminated and the H plus ion is broken down and you finally get C2H5O C2H5. This is your SN2 reaction mechanism. Careful, the nucleophile is attacking. So this is your SN2 reaction mechanism where two molecules are participating in the rate determining step. Okay, this is your dehydration of alcohol, the mechanisms. Careful, I've explained this. Now next one we are going to go, what is the next reaction? Williamson synthesis. Careful before we go to this physical properties. Williamson synthesis. So maximum students get confused here in Williamson synthesis. Don't get confused, it is easy. Williamson synthesis. Okay, so basically what is Williamson synthesis? Williamson synthesis is nothing but conversion of alkyl halide combines with sodium alkoxide. Alkyl halide is combining with sodium alkoxide to form ether. Now in this there are different conditions. Different conditions. What did I say? Your alkyl halide is combining with your alkoxide and it is forming an ether and NaX. Correct? Huh? Now here careful, this alkyl halide, it can be 1 degree, it can be 2 degree or it can be 3 degree. Now this alkoxide, it can be phenyl ring, it can be 1 degree, it can be 2 degree, it can be 3 degree or it can be methyl group also. Okay, right? Now careful. Now we will see the conditions in different way. First important thing, condition number 1. Suppose I have a alkoxide as phenyl. Okay, I have an alkoxide which is phenyl. Then your alkyl halide CH3Br is combining. If you have a bulky groups, careful, if you have a phenyl or larger bulky groups, you will always be getting a bulkier ether. Careful. Got it? Yes. Suppose condition number 2. Careful. Suppose if you have a smaller alkoxide, okay, smaller alkoxide, a primary 1 degree, and you also have a smaller alkyl halide. So both conditions I am giving: smaller alkoxide, smaller alkoxide, small alkyl halide. Got it? So then what happens? Careful. In this case, bromine is more electronegative, it pulls the electron density. Then oxygen comes and, because this becomes positive, this becomes negative, the oxygen comes and donates its electrons to this carbocation. So then you will be getting your ether. Careful students. So that means when it is when it is phenyl group, then you will get the larger ether. Suppose if it is in this case, when you're getting a primary alkoxide and you're taking primary alkyl halide, you will be getting ethers. Is it okay? Now condition 3. I'm continuing in the next page because I don't have place. Condition 3. Yes. Suppose if you have tertiary alkoxide, careful, tertiary alkoxide, then what happens? You are having your primary alkyl halide. Now what is changed? Same, positive, negative. This drags the electron density. Yes. So the negative goes and donates its electron density to this carbocation, and you'll be getting your tertiary ethers. Yes, careful, tertiary. So if the group is bulky, remember you will be getting tertiary, means you will be getting tertiary ethers. Is it okay? Yes. Now option D. Suppose if you have your tertiary alkyl halide, like this, okay, and you have your normal alkoxide, smaller group, normal alkoxide, then what happens? There is a cleavage of the bond here, and this bond is picked up by your CH2. Yes, this you have your Na, C2H5ONA, the C2H5ONA, this is there now, I have written in the reverse order, so I'll write it normally, C2H5ONA. So your whatever bond is here between CH2 and H, that shifts here, and your Na plus and C2H5O minus, that H whatever is there, that negative charge is given to your positive charge, this H. So finally I'll be getting your alkene. Got it, students? Yes. So see the conditions. Once again I'm revising. If it is tertiary alkoxide, you'll get a phenyl alkoxide, you'll get a phenyl ether. Suppose if it is primary, you'll get a primary ether, if both alkoxide and alkyl halide are primary. Suppose if you have tertiary alkoxide, you'll get tertiary ether, means an ether with CH2H. Suppose if you have a tertiary alkyl halide, you will get an alkene. Okay, remember that combination. Okay, easy. So note it from here. This is condition 1, this is condition 2, this is condition 3, this is condition 4. Now these are the physical properties. So as you know, miscibility with water, if you have, if you compare with the alcohols and ethers, yes, miscibility with water resembles like those, almost similar but less. Alcohols are more soluble because of hydrogen bonding. These are more soluble compared to ether. They are also, but hydrogen bonding is less. Then boiling point, it's lower than alcohols because hydrogen bonding is present in alcohols. Boiling point is more than ethers because of hydrogen bonding in alcohols. Easy. Next question. So one more thing. Ethers, when I show because of the resonance, there is shift of pi electrons. You will be getting a negative charge at the ortho position, para position, ortho position. Okay, so because of the formation of negative charge at ortho, para and ortho, it will be showing electrophilic substitution reactions in which one? At ortho substituent and para products. You will be getting ortho products and para products because of the resonance. Is it okay? So double bond can't be together, so it will be showing ortho para directing reactions. Correct na? Alright, so let us see the one flow chart. I'll show you. See this. These are complete reactions of your chemical properties of ethers and anisole. I told you, anisole, it shows electrophilic substitution reaction. In bromination, it shows para-bromo and ortho-bromo products. If it is alkylation, it shows ortho and para products. If it is acylation, it shows ortho and para product, where para is major. If it is nitration, it shows ortho and para product, and that both para is the major product. Apart from that, ethers also show cleavage of CO bonds. Okay, the cleavage of CO bonds, where when ethers react with HX, they're going to form alcohols. I'll explain this. And ethers are reacting with HX, this. Okay, I'll explain this part now. Okay, let us understand what is this part. I think remaining all are easy. Let us understand. So basically we are going to talk about chemical reactions of ethers. This is important. Chemical reactions of ethers. Now first thing, ROR, I'm reacting with HX. Okay, so what happens here? First of all, the bond breaks. I'm getting ROH and RX. There's no big deal in this RX and ROH. Now the complication of the mechanism here is when it breaks, the mechanism part. Careful, just see. ROR prime rather. There are 1, 2, 3, 4, 5, 6. Now H, in that HX na, H plus is acting. So this lone pair of electrons are donated to this H plus. What do you get? You get, then because R oxygen is donating, this gets a positive charge. Right? Careful. Now if R is small, if R prime is smaller than the is a small thing, smaller group compared to your R, then Careful once again, if R group is smaller, if R prime is small group, then the R, then smaller than alkyl group, small than R, then what will happen? It will show SN2 reaction and you will be getting your R prime X and ROH if it is small. Okay, right? Careful. Suppose in this case, if R prime is tertiary alkyl halide, means if it is big, if the R group is big, then what will happen? Careful. If R group is tertiary, R group is tertiary alkyl halide, then you are going to get R as OH and your alkyl halide will become your R will become your RX. Got it? Your alkyl, if this is bigger, it will become OH. If it is smaller, it will become RX. Is it okay? Clear, students? So easy? Okay, that's the concept. Now let us take one example and see how we are what did we do with this. Okay, chalo, let's do one thing and understand. I have both the ethers are, both the alkyl groups are same, R and R are same. Then what do you get with your HI? You will be getting same, na? CH3I plus CH3OH, because both are same. Okay, right. Now condition 2, one I will make it small, one I will make it big. Now this is R and this is R prime. Now what did I say? If the R is big, then what happens, CH3, see here, this is H plus O minus, na? Oxygen is going to donate the electrons to proton and you will be getting positive charge, hydrogen, CH2, CH3. Okay, done. Now I minus, what will happen to this? This will undergo SN2 reaction. Now I minus comes and attacks this oxygen atom and you will be getting CH3I and CH3, CH2OH. This is the product. Okay. Now condition is, I am going to take this R as a bigger group. I'll take this R as a bigger group. Now OCH3. Now same thing, I am introducing H plus I minus. The oxygen atom, this whole thing, na, yeah, it tries to donate its electron pair to hydrogen. So I'll be getting a tertiary thing where your O plus and CH3 and H. So the lone pair of electrons whatever are there, because oxygen can't have positive, so the lone pair of electrons is pulled by oxygen atom and I'll be getting a tertiary carbocation. Correct. Then what will happen, and remaining is your methanol, CH3OH. Now your iodine comes and attacks this and that is your plus I effect and you will be getting this whole tertiary carbocation. You will be getting your CH3, CH3 and I. Correct, na? Yes, one is the tertiary and one is this one. Easy, very easy. Chalo. Now next important thing, suppose if you have deep thing, we'll see. Suppose if you have your tertiary, means the group here is phenyl, then what happens? 1, 2, 3, 4, the bond shifts here. You have this bonds here, right? If you take this, like this, both double and double can't be here, this shifts. So when you take HI in this case, careful, you will be getting phenol. Okay, you will be getting phenol and CH3I is out in case of phenyl rings. If the R group is phenyl, Okay, right? So now, ma'am, why is this happening? We will see the mechanism for this. This group is there. Now let me take that OCH3. Now your H plus is there. Oxygen is donating its pair of electrons to H plus. Then what happens? You will be getting your oxygen positive, the CH3 and your H. Now what is attacking to this? Your I minus is attacking. Okay, so I minus goes and donates its electrons because it's unstable. This follows back, that is SN2 attack. Then I'll be getting my OH, then I'll be getting CH3I. Easy. This is the mechanism. Careful. And anywhere, if you feel like any doubt, please ask me in the comment section. Okay, right. Let's go and see this. The major products of the reaction. Okay, major product. Now what did you observe in all this? What is this? This compound has CH3, CH3, CH2, 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 CH3. Okay, now this part is your R group, this part is your R prime group. Now this is larger enough, just now we have seen see this one, this group, correct, larger enough. So when you have larger group, just observe. In this case also, see this R and R prime, I told you na, what will it do? It's going to take up the smaller one. So come back, it's one, the bigger one is going to take up the alcohol and the smaller one will take up the I group. Easy. Next question. Williamson ether synthesis is used to prepare ethers. Okay, next one, ethanol has a higher boiling point than methoxymethane. Give reason. So ethanol, reason nothing, only you write one, because of intermolecular H bonding in ethanol. More the hydrogen bonding, more is the boiling point, correct? More is this, that's why the boiling point is more. Okay, next question. Write the chemical reaction of HI with methoxymethane. Okay, methoxymethane, let us understand. Oxygen 1 2 3 4, methoxy, then HI. Simple. Associate to reversible reactions. Oxygen atom positive, hydrogen and I minus. Okay, now the I minus part will attack the hydrogen, it's going to form a transition state, and further this breaks up into CH3I plus CH3OH. That's all. Chalo. Next, ethers are relatively inert. Why? Okay, why they are inert? Because here in ethers there is an oxygen atom, correct, and this is a divalent oxygen, correct. That divalent oxygen, there is no active site na? Because of this divalent oxygen there is no active site. That's why ethers are inert. Hence ethers are relatively inert. That's all. Next. Okay, such questions is important. Just see careful. Two compounds A and B have molecular formula C2H6O, and on reacting with HI, A gives alkyl halide and water, while B gives alkyl iodide and alcohol. Identify A and B. Correct na? Okay. So first of all, let us understand the reactions. Careful. They said A gives alkyl iodide and water. Correct na? So compound A. Let us first identify step 1. Identifying A. They said A gives alkyl iodide and water. That means the formula, what did they give me? C6Ac2H6O. So it is nothing but C2H6O is alcohol. It reacts with Hi to give. That's all. How did I know this? Because Hi, simply water is removed and iodine is given. Easy. So A is this. Then they said step 2, they said B is reacting, gives alkyl iodide and methanol. B. So step 2, I am identifying B. It has given alkyl iodide plus methanol. Correct na? Yes. So alkyl iodide with methanol means there are 2 alkyl groups where you are adding 2 Hi. That's all. So dimethyl ether, step 2, they said. So the final answer which I got is, I have a place, okay. The final answer which I got, A is ethanol and B is dimethyl ether. Dimethyl ether. That's all. How did I know? By knowing the products. Next question. This is a blank page. Let us come back to the next question. A compound C4H10 is formed to be soluble in sulfuric acid. It is found to be soluble in sulfuric acid. A does not react with sodium or KMnO4. On heating with excess of Hi, it is converted into single alkyl halide. Identify compound A. So first of all, let us understand how many pages I have. I have 1, 2, 3. Okay, I have pages, so I can comfortably explain you all. Chalo. Let us understand first a compound A, C4H10O. Okay, so first step 1. Let us understand step 1. C4H10O compound. They said this is soluble in sulfuric acid, H2SO4. Then they said it does not react with KMnO4 or sodium. It will not react with sodium. It will also not react with KMnO4. And they said on heating with Hi, it is converted to single alkyl halide. So they said when you are heating with Hi, you will be getting single alkyl halide. Okay, single alkyl halide. I am just noting the information. Okay, so what is that? So when it is dissolving in acid, means it indicates it is an ether. Okay, it is an ether. Why? Ether will form an ion called oxonium ion. Oxonium ion with salts, with acids. They form oxonium ion with acids. Okay, it is not reacting with sodium or it is not reacting with KMnO4, means it is not an alcohol, because alcohols react, na? It will react, alcohols will react with both sodium metal and KMnO4. So it suggests it is not an alcohol, because alcohols normally react. It forms single alkyl halide, means compulsory C4H10 is a symmetrical ether. Symmetrical ether. This is the basic understanding. Now let us go to step 2. This is understood, I think. Now let us go to step 2. Now step 2, what is it? They said. Now let us come to the formula. C4H10O should be an symmetrical alkene. That's nothing but C2H5O. C2H5. See this, count 2 plus 2 4, 5 plus 5 10 O. So this is diethyl diethyl ether. Got it? And this diethyl ether, it will not react with sodium, it will not react with KMnO4, but it will react with HI. Correct na? Yes, done. Now step 3. They said C2H5O C2H5, it reacts with HI and it gives me single alkyl halide. Single alkyl halide plus water. This is single alkyl halide. Correct na? Yes. So what is the compound now? What is the compound? Whatever we got. So option A, do I have place? Yes, I have. So A is basically C2H5O C2H5. That is nothing but diethyl ether. Easy. So this is the reaction and this is the final answer. Clear, students? Chalo, go back and answer this. This is the answer. Chalo, next question. Explain alkyl aryl ether directs the incoming substituents towards ortho and para position what? Simple. When you see this in alkyl aryl ethers, you are seeing due to resonance, you are able to see the negative charge at the ortho position, para position. That's why whatever incoming electrophiles are there, it's going to send them at ortho and para, forming OP directing groups, OP directing products. Correct? What will you write? You will write due to resonance, it shows negative charge. It shows negative charge at ortho and para positions. Hence, incoming substituents are ortho para direct. Okay. Next question. Identify the product. They have given this. They have given me sodium borohydride. What is this particularly? Sodium borohydride is a reducing agent. Correct na? So when such reaction is given to you, simple, nothing, it's easiest reaction. I'll tell you how to do it. This molecule is there na? What is this molecule? This is cyclohexanone, this part, and 1 2 3 4, it is 4, I'm writing here, butanoate, and there is a methyl group, methyl ester. This is the group. Now such sodium borohydride is given what to do. So basically remember, NaBH4 is showing selective reduction. So what you're going to do? Nothing, simple. Your whatever cyclohexanone is here na, this compound, this molecule, it's going to get converted into just nothing. Wherever your molecule is there, you are going to introduce your OH group. Okay, so hexanone, wherever oxygen is here na, this oxygen, hexanone, it's going to get converted to your OH group. But ma'am, this is your hexanone, this is your ester group. Correct na? So your whatever ketonic group is there, that ketonic group is going to get converted to your hydroxyl group. Ma'am, right? Reaction please. Yes, the reaction is this way. You have your C6H10. Correct na? Then you have C double bond O. Then you have your CH2. Correct? Then you have your CH2. Correct? Then you have C double bond. Then you have OCH3. This is the molecule now. This one. Okay? Then this is doing selective reduction. The same molecule will become C6H11. C, the O group becomes CHOH. then your CH2. This is a compound. So basically your hexanone, whatever is there, is reduced to cyclohexanone, is reduced to hydroxyl group. It is reduced to hydroxyl group to form hexanol. Do I have place? I don't have place. To form cyclohexanol. Okay, so here whatever ester is there, this ester part, it remains unchanged. Reason, careful, ester part remains unchanged. Reason here is sodium borohydride cannot reduce esters. Okay, done. Chalo, next question. Okay, see it, this is given tertiary. Okay, the R part here is given tertiary, the R prime part is given smaller one. So what do you get? What product do you get? Basically, yes, simple question, na? So you will be getting your tertiary iodide plus methanol. Easy, very easy. So because it forms tertiary carbocation, na? Okay. Next question. I have, okay. Tertiary butyl chloride on heating with sodium methoxide gives 2-methyl propene instead of tertiary butyl methyl ether. Why? Okay. So the solution part, let me start. So basically, what is understanding? What should we understand? They said tertiary butyl chloride. Okay, what is that? It is CH3CCl. This is a tertiary butyl chloride. It's reacting with sodium. Okay, sodium methoxide under heating conditions. Okay, and they said it gives 2-methyl propene instead of tertiary butyl salt. So it is giving me 2-methyl propene, this one, and it is not giving tertiary butyl methyl ether. They are asking why. Great. Understand. Here first reason is it is dominating, it is even E2 or even reactions are happening, instead of SN1 or SN2 reactions. That means here elimination is dominating substitution reactions. Elimination is dominating substitution reactions. That's the main concept. Okay, so when I see the reactions, if I have to understand careful, they said step 1, tertiary butyl chloride, it first breaks up into tertiary carbocation plus chlorine minus. Correct? Now this first thing, tertiary alkyl halide, this is stable, right? Yes. Yeah. So in the presence of a strong alkyl, in the presence of a strong base, this is a strong base. So what happens in the presence of strong base? The tertiary carbocation, whatever is there, it undergoes elimination reaction, and it forms a alkene and H plus. So this elimination is called beta elimination. It moves from beta, leading to the formation of 2-methyl. It's nothing but isobutene. Isobutene. It's nothing but 2-methyl propene. 2-methyl propene. Okay. So this is a major product. Got it? That means That means overall reaction if I have to take, the overall reaction I'm taking your tertiary alkyl halide, not alkyl halide, so we have written here tertiary butyl chloride, alkyl halide rather, with your sodium ethoxide. This on heating is going to give me an alkene plus NaCl plus methanol. This is the compound. So careful, they asked me one more question. Why explain the following, they said. So what will you write? Explain the following means what will you write? Yes, you will just summarize it, saying that in this case, instead of substitution reactions, elimination is dominating. Okay, yes, dominating under heating conditions. Okay, under heating conditions to form, like basically 2-methyl propene. Heating conditions to form 2-methyl propene. Okay, got it? Understand this. Okay, next, let us see one more question. I think we are almost coming to the end of this. We have 2 more questions to do. Let us do this. An ether with formula C5H12, when heated with excess or concentrated HI, produces 2 alkyl halides, which on hydrolysis forms B and C. Oxidation of B gives D, whereas oxidation of C gives E. Deduce A, B, C, D. Okay. So first of all, C5H12O, when heated with concentrated HI, produces 2 alkyl halides, they said. So first of all, C5H12OA, so basically the molecule C5H12O is nothing but ethyl isopropyl ether. Okay, it's C2H5OCH, CH3 taken twice. You're adding 2 molecules of HI. They said it is giving an alkyl halide and it is giving a it is giving 2 and 3, it produces 2 alkyl halides is what they said. It produces 2 alkyl halides, what they said. It's producing 2 alkyl halides. Right? Now, then this is your A part. So basically A is your ethyl isopropyl. Next, what did they say? Ethyl iodide and isopropyl iodide, okay, both are formed. Now they said B, oxidation of B gives an acid. So let us take this as B, let us take this as C. Now they said B on hydrolysis gives me an alcohol. B on hydrolysis, they said, what did they say? B on hydrolysis gives an acid. Okay, B on hydrolysis gives an acid, they said. So I have to take this B further. This combines with oxidation and forms acid. It's acid. Okay. So an oxidizing agent is potassium dichromate and sulfuric acid. So the D is this, A, B, C, D. Okay, D. Done na? Then they said your C, whatever is there, is reacting with C gave a ketone E. They said C part has given a ketone. What is the C? I am taking this. It's reacting with water and it forms an alcohol, means OH plus HI. It is tertiary na? Yes. So C compound is giving me D. Okay. But they said it is giving me ketone, they said. So this compound further undergoes oxidation in the presence of potassium dichromate, sulfuric acid to form ketones plus water. This is your compound E. Okay, alright. So before we go to this question, so let us once summarize what is A, B, C, D. So the A part which I got is C2H by O, CH, CH3 taken twice. It's ethyl isopropyl ether. Correct. Then B part is ethanol. Correct na? Correct only na? B part. Did we write B part as no? B part forms B part ethyl iodide reacts with B to form ethanol. So this becomes no. This will not become B. It reacts forming ethanol. Okay, this is B. Correct na? Yes, this is B. So B part is your ethanol. Then your C part is iso products. I am writing, students, products CH3 CHOH. This is isopropanol. Please write all the products. I have written the reactants earlier. And your CD, basically D, what did I get? D, let us see. D is acetic acid, correct na? D I got as acetic acid, all the products, students. And your E is ketone, acetone. Please write all the products. I just wrote it here. Please write the products. Careful, write the products, students, because they've asked draw the structures of A, B, C, D, E. So that's why I've taken all the products. Got it? Shalom. Next question, a bigger one. Okay, I should draw the structures also, no? So I should draw the structures also. Can you draw all the bond line structures for this? Draw the bond line structures like this, please. Okay, then OH, then acetic, your isopropanol, now all the structures. Then D part is acetic acid, it's the same, and ketone, draw the structure. That's all. Okay, so next question, basically, okay, this is one more. An ether C5H12O, when heated with excess of concentrated HI, produces two okay, this is already done, I think, huh? We just did. Okay, little bit difference here is formula. I think this is the same thing which we did already, I think. Hot concentrated HI. Okay, so almost a similar reaction, no, students? It is the similar reaction. Everything is similar. I'll try to do in a simpler way. It's almost similar. I'll just finish off and making the concept easy. It's almost a similar reaction. Let's see. The reaction first, C5H12O when heated with concentrated HI gives two alkyl halides. I think similar only, no, students? The same reaction here. Let us see. It's the same reaction. Okay, sorry. Repeated question this is. So this is a repeated question. Sorry, already done. I think 2 times they did the copy paste part. Okay, this is your blank page. Okay, right. So done. Yes, perfect. We have successfully completed 100% of your 100% completed. We have completed some 100% completed here. Alcohols, phenols, and ethers chapter. And ethers, perfect. So all MCQs completed, 1 mark completed, 2 mark completed, 3 mark completed, 4 mark completed, and 5 marks completed. Yes, I'll be meeting you with the next chapter, that is aldehydes, ketones, and acids. So stay tuned, please. I want all of you to please like the video. It took a lot of time for me to do this video. Share the video and subscribe to the channel. because I'm going to do your NEET series. Yes. Chalo, meet you with the next chapter, aldehydes. Thank you.